Hello, we're back now for our second lecture, our international lecture provided by Andifes Destination Brazil. And during the second lecture, we're going to be talking a little bit about strategic minerals, especially in Brazil, but we're going to also cover Europe, United States, Canada, and a little bit of India. So again, if you have any doubts, please let me know anytime. Just raise your hands or just open your mic and talk to me. Okay, I'm here to talk to you guys, not only to talk to myself. Okay, so please let's interact. So first of all, we have to understand a little bit about what is critical. What is the definition of this word? Okay, normally when we talk about critical minerals, we want to address to minor metals. Okay, we're going to see that we have other elements in this same category, not only metals, but normally when you talk about critical minerals, you automatically drift to minor metals, but that's not only the case. Okay, but now we have to consider that critical is one word, and it's a very good word to start this lecture, but also so strategic. Okay, so what is strategic to us? When we consider Brazil, I showed you on our last lecture, first lecture, what is Brazil good in regarding mining? Okay, so we're the largest producer of niobium. So is it niobium critical for Brazil, or niobium is strategical to Brazil? Okay, so these two definitions are quite important for this lecture, and I'm gonna try to explain more about this. Okay, so minerals, they are essential ingredients for our survival. Okay, and if you want to thrive as a human race, we definitely need minerals. Okay, and that's why we've been mining for the whole human time in this globe, and I think that we still gonna be mining for the next hundreds of years. But mining is changing, and I'm not talking only about the size of the equipment, as you can see in this picture. Okay, it's a very beautiful picture, of course, but when I was an undergraduate student, my professors, they didn't want to talk about things like circular economy. First of all, because we didn't have this concept, but they didn't want to talk about recycling. They didn't want to talk about water shortage, okay, water supply, and even about environmental questions. So we have this idea that we had to do mining, and mining alone, okay? And nowadays we can see a broader picture, okay? We can't just remove mining from the globe as mining being something completely away from planet Earth. That's not the case. We're part of the planet and we have to deal with that. So we want to mine, sure. We need this mineral resource, of course, no questions asked. But we also need to remind that we have to do mining in a safe way. Okay, and when I talk about safe way, I'm meaning about all the meanings of the word safety. Okay, economical, social, environmental, everything. Okay? And that's why we have to take a look again into mining as an operation, okay, and also as an industry. So I think this chart, it's quite nice. It's the global mining project development, and it can show to us a little bit the mining process and the mining projects that are nowadays ongoing. And this chart coming from December 2020, okay, so a few months ago. As you can see, the whole world is mining or intend to, and that's quite nice for us who's dealing with mineral processing, because there is no mining without mineral processing. And if you're going to be mining, you have to process it. Okay? I know that we didn't talk deeply yet about mineral processing, but if you extract the ore, you have to separate the ore from the other gangue minerals. And that's why this chart is so important for us. And another thing that is quite interesting, everything is in the billion of dollars. Okay, we're not talking about million of them, we're talking about billion, even in Europe. As you can see on this chart, we have Portugal, Spain, Germany, UK, all around. Okay, definitely we have a huge concentration on Central Asia, but we do also have similar concentration in South America. As you can see, South America, we're talking about almost $200 billion. Just another one. And when you talk about Central Asia, only 30, okay, just around $30 billion. And US and Canada, definitely, they are around. Africa, again, a major player in mineral research around, and Russia too. As you can see, we have exploration, scoping, and feasibility study. We have advanced planning permit, and that's why USA and Canada are so ahead of us. We have also approval and engineering stage, construction. Everything is covered in this chart. So guys, if you're an undergraduate student related to mineral processing or mining engineering, you're actually quite lucky, because the next couple of years tends to be very good years for us. As you can see, in Latin America, we're pretty much in the scope and feasibility study. And I've been working with or talking to guys who is just at this stage, and I think in 5 years we're gonna see a blooming in mineral processing and mining in Brazil, all around Brazil. I'm not talking only about Minas Gerais and Pará, Bahia, Goiás, even on the southern part of Brazil, like Rio Grande do Sul. So good things are coming to us, okay? Just keep our fingers crossed, and I think we're gonna have good surprises, okay? So again, strategic and critical. And I saw this picture online. The website is below on your right-hand side, so you can check on this website later on. I strongly recommend you to read it. It's quite nice approach about this. But the author was, again, discussing about strategic and critical. So all the time, you're gonna have to make these questions to us. Is this strategic or is this critical? So we have some definitions for this. Normally, when you talk about strategic, you're talking about what? Military. But before we get to that, how about this logo? This logo means a lot to us, right? Everybody knows this logo. It's just an apple, okay? It's not only an apple. And as you can see, it's a slightly sliced apple, and someone just took a bite. Okay? So it's like half discussing apple because someone took a bite of my apple. But when we see this, no matter who we are or where we are, or if we have been in touch with some product of this company or not, automatically we think, oh, this is strategic. Okay, this company, it's something, means something. And why this company means something to us? Okay, it's not because of the logo. Okay, it's not only because of the logo, but it's because this company reaches a market value of $2 trillion. It is amazing. Just one company who can be around all places in the world, who can be found in all places in the world, reached $2 trillion. And not with only one product. They are a major player in many products nowadays. And if we come back in history and take a look about when all this started, it started around 1976 when Apple was founded. And 4 years later, they started their IPO. So they were nothing. If you take a look at the market share, they are nothing. And they remained almost nothing until 2005. Okay? Take a look at this. We're talking about almost 30 years being nothing in the market. And then Apple's miracle started to happen. And in just 13 years, they reached $1 trillion. And then 1 year later, $2 trillion. Okay, they double in 1 year. And we talk about the beginning of the pandemic because we're talking about August 19, 2020. Okay, and this is the first time that a US company reached $2 trillion. This is more than all the Brazilian market share, and it's an amazing number. It's a huge number. So definitely, Apple is a strategic company. Okay, Apple is critical to the United States. Brazil should have an Apple too. Every country should have an Apple too. But what is the difference, the main difference between Apple and mining. Okay, because we're talking about mining. We're not talking about cell phones, right? Wrong. We're talking about technology. It's all about technology. Because one of the greatest minds in our time, Steve Jobs was one of those, and that's why I'm here homenaging him using this logo to have his face on it. But Bill Gates said that nowadays, the most valued commodity is information, it's knowledge. And he was right, okay? So now we're talking about technology. So what kind of elements can we find on a smartphone? Of course, many. But if you take a look at the screen, we have indium, oxygen. We don't care about oxygen, okay. But we have tin, aluminum, silicon, oxygen again, potassium, okay, and we have rare earth, okay. We have indium, we have lanthanum, we have terbium, we have praseodymium, europium, dysprosium, gadolinium, and so on. And that's just the screen, okay. So again, if you take a look at the battery, lithium is going to pop up, definitely, but cobalt, it's also important. If you take a look about the electronics, you're going to see tantalum, okay, but other elements are also important. So if you relate this information, okay, what information again? Apple as being the first company in the United States of all of those companies to reach $2 trillion market share. 2 trillion, okay? Vale in Brazil doesn't have this feature. And if you go to the other hand, about their own products, they are technological products, okay? And we need a lot of elements to supply this demand. So everyone wants an iPhone. And if you want an iPhone, you're gonna have to buy strategic minerals because it's all about mineral. Who do you guys think is going to supply these chemical elements to them besides us? Just one other player, okay? So nowadays you have two options to get your hands on indium. Or you mine indium or you recycle, okay? And that's why it's so important to talk about circular economy. And we're gonna have some discussions about this. So this one over here, this document over here, I just make some cuts out of it to prepare the slides. This is the product environmental report of the iPhone 12. Okay, take a look at this. They have an open product environmental report available online. You can just go down there, go there and download it. And what is standing over there? One thing that's quite important, how they got the strategical elements. So 99% of all tungsten present in your iPhone 12 is recycled. Okay, just 1% coming from a new source. A new source means mining. Okay, regarding the rare earth elements, we reached 98%. And that's huge. Why? Because it's not so easy to recycle rare earth elements. That's on one hand. On the other hand, it's the first time. This is the first time that a smartphone has 100% recycled earth elements on it. So you just mentioned 98. Yeah, the other 2% coming also from recycling. So iPhones right now, they don't need to mine new rare earth. They can go on just recycling. 98% recycling from one hand and 2% coming from other hand, okay? And they have more information about energy efficiency. They reached 53%. Okay, this is huge because if you take a look at the Volkswagen Beetle, the energy efficiency is just 8%. Okay, so your iPhone, it's quite efficient. And if you take a look also about packing doesn't mean a lot for anyone. I think for all of us, I think I can speak for all of us. We just take the iPhone and throw the packing away. Okay, some people just keep the pack around, but just for a short time, I guess. We just throw it out. And they are using 100% of recycled material, okay, regarding wood fiber and other stuff. So consider this. You went to a store and you went to an Apple store. So it's a huge store a lot of beautiful people around. The smell of the store is quite nice, so they spent a lot of money on that store. Okay, and then do you decide to buy a very, very fancy and expensive phone? You took an iPhone 12, and when you receive this amazing product, an amazing technology embarked on that device, you receive almost everything recycled. Okay, so if you had this information like 10 or 15 years ago, you automatically will think, oh, this is garbage, because recycled material is garbage. Take a look at the paper. Okay, it's worse than the original one, the first one. Okay, and nowadays it's all upside down. Okay, you want recycled thing. It's okay to have recycled thing. It's good for the environment. So the mindset completely different from the beginning. Okay, and we're in the middle of this. Your guys growed up in the middle of this, and that's amazing. Okay, because that's the way to do it. Okay, I'm 100% okay and supporting circular economy. Okay, this is not only strategic, this is critical. If we don't do this, we're not gonna have planet Earth available for us in the few decades. Okay, so we have to keep that in mind. So moving on, what do we have in this product environmental report from December last year? That's quite important. Oh, sorry, October last year. That's quite important for us. Again, tungsten, rare earth, plastics, and tin. Okay, tin. If you take a look at tin, it's quite strange because over the years, tin mines are just running out not because of the complexity of the ore or because they are short on grades, but because of the price. Tin was so cheap, they're just closing their mines, especially in the UK or other countries. It doesn't pay off. Let's just close the mine. And now we come to this highly desirable product, and they look at you and said, okay, we use tin and we demand a lot of tin, and we use 100% recycled tin. Okay, so it's quite interesting. It's quite interesting, guys. What I'm using a lot of time to talk about iPhone with you, because iPhone is just the tip of the iceberg of all technological products that are around of us. Okay, your computer, your camera, webcam, your smartwatch, everything, even your car. If you consider a Tesla car, it's going to be pretty much the same. Okay, so those elements, they are quite important for the new world. Okay, and if you want to keep moving in that direction, what direction? Industry 4.0, IoT, and things like that. We need those guys. Okay, we can't just move away, not at least now. So this chart shows to you a compilation of many published material from different countries. As you can see, we have Canada popping up, the names Canada, the flags of Brazil, Canada, Chile, South Africa, but we have information also about India and again, Brazil. Brazil is also in this chart. What this chart means, okay, what this slide is bring to us. Those are the publication of your governments about strategic minerals. I tried to collect some of figures about the last 5 years, okay? But some countries, it's quite difficult to find those. Okay, normally it's like classified documents and things like that. It's not completely available online. What I think it's not a very good way to do it. I think we should come public about this situation. But some figures that you can take a look, some icons just pop up. For example, airplanes, wind turbines, okay, new lamps, bulb lamps. You can see e-mobility in the way of cars driven by electricity. You can see solar panel, a lot of those. It's coming around new energy cells, and I'm talking again about electrical energy. But you can see also gold. Gold is the main thing in the picture. When you take a look at gold, everything was not so shiny. Okay, everything comes to gold. But again, this is what your country consider, or a group of countries, because EU is also in here in this chart. So Europe in general is in this chart, but you can see that we have something written in Deutsch, in German, okay? And again, this is important because of what? Because your government is openly telling to you what they consider strategic or critical for the country, okay? So we have to take a look at this and see how our country is dealing with this new situation, with this new world that we live in, okay? Again, we have Internet of the Things. So everything is going to be online, even your fridge. Can you imagine this? You're working and then you just receive a message. It's not an SMS anymore, it's just like a WhatsApp message, and it's your fridge talking to you. Okay, you're running out of milk. Should I order more or wait for you to come back home? I said, okay, I have now 2 wives. I have my fridge and my wife. And yeah, the fridge is going to do this for you. The fridge is going to order things for you. And when you arrive, things are right there waiting for you, okay? And I know we're staying home because of the COVID-19, but I'd like very much that I was just working and my fridge do the shopping. So I don't have to stop working to go to the fridge, to take a look and make notes, and then go to a supermarket, buy things, come back home. When you take a look at this, your time, it's precious, okay? It's the only thing that we all sell, and we don't have a way to buy more, okay? So if I can use my time to order things, I would like very much, okay? So let's move on. This is the Brazilian plan for strategic minerals, okay? This is from 2017, because it was covering 2018 up to 2022. So we have more publications after that, but this one is the plan that's actually ongoing right now, okay? Again, from 2018 up to 2022. And many players in Brazil came together to develop this document. The first one, and of course the most important one for this plan, is called ANM, which stands for the Brazilian Agency for Mining, okay? And then we have the Serviço Geológico do Brasil. And Serviço Geológico do Brasil, it's something quite similar to what we have in the United States. And over there we have the USGS, would be the Geological Service or Survey from the United States, okay? It's the same in Brazil. They do exactly the same things, okay? And even the publications that we have in the United States come from the USGS, and you guys are going to take a look at their website today, because it's quite important for us to know more about USGS. We have in Brazil in the ways of CPRM, okay? Then we have the IBRAN, okay? We don't call this IBRAN, let's call this IBRAN because of the Portuguese. And IBRAN is the Brazilian Institute of Mining. It's an institute separate from the government. And then we have another branch of the Brazilian federal government in the way of CETEM. And CETEM, it's quite important to mention because we do have research and development for mining coming from the universities, but we have just one other option beside the university and not from the private sector, and that's CETEM. So they are researchers connected directly to the federal government, but they are not in a university. They are not professors. Okay, they just only do research, and that's why they take part on this too. Okay, and we have the Brazilian Ministry from Science, Technology, Innovation, and Communication. So this huge ministry, they do 4 things, and 4 very, very important things. Again, science, technology, innovation, and communication. So if you guys think a little bit about what I just said, the world that we live in, and the Brazilian ministry that is behind this plan, we can take a look in advance what kind of elements we expect to see in this document, right? So the guys coming from science, so they know science, they know technology, they know innovation, and they do communication. So it's all about what we're talking right now, okay? And that's why I start with Apple, okay? Because Apple is science, technology, innovation, and communication, right? Yeah, not exactly, but we're gonna get to that, okay? So again, what is defined as strategic? Because I just talked to a lady and she told me that she's come from Pará. And what is strategic in Pará? Probably things that you need in Pará or you produce in Pará. So what is strategic in your country regarding minerals? Okay, probably a mineral that you demand a lot or a mineral that you can't supply. So those definitions are quite correct. Okay, and if you take a look at Brazil, niobium is definitely strategic for Brazil. Why? Because we're the largest producer. Iron ore is strategic to Brazil. Why? Because we sell a lot of those. Okay, so it's quite important for us regarding money, regarding our GDP. How about, I don't know, gravel, sand? Are those strategic minerals? If you consider that you're in a huge place, huge civilized place, you demand a lot of concrete. Okay, concrete is the second thing, let's consider this word for now, thing more consumed by human beings. The first one is water. Okay, so if you want to see how developed a country is, you take a look on how much concrete this place demands. Okay, so if you think something like that, and you consider that concrete is made pretty much of Portland cement, okay, one item, water again, second, but gravel and sand. So gravel and sand, they are definitely strategic. How can I make concrete without those? It's impossible. And it's so strategic that if you take a look in Brazil, and I'm talking about top to bottom regarding north to south, you're gonna see this changing. And some place you're gonna see granites being converted, being grinded into gravel, okay? And in other place, they take just calcium carbonate. And it's quite strange because if you add water to calcium carbonate, and this water have an acid pH, it's gonna have a chemical reaction. But they do use this, and they build up buildings with those materials, okay? Because they don't have other materials around. So it is strategic to take a look at this, because why? You have to supply those, okay? And the demand is high, okay, guys? So that's why it is strategic. What is strategic to Ouro Preto? The minerals that Ouro Preto can supply, okay? Well, but Ouro Preto is not supplying minerals anymore, okay? But what kind of minerals Ouro Preto demands? Those are strategic. I have to take a quick look and a deep understand about those. Okay, so let's keep with this definition. So moving on to United States, okay, United States has USGS. It's great, it's the Geological Survey from the United States. So these guys, or those guys, they take a look at everything, okay, literally everything regarding geology, they are taking a look. So they cover 90 commodities, okay, 90. So for United States, 90 different commodities are considered strategic. How about Brazil? 4.
Excuse me,
4.
Professor.
Yes, please go ahead, Diane.
In the case of gems, and you
Gems.
see Ouro Preto, and I remember of Imperial Topaz. I don't know.
Yes, I know. Yep, please go ahead, continue.
I don't know, in the case of gems related to strategic minerals, if there's some difference because of the demand and the market.
That's a very good question, okay? Or at least you give me something to talk about. You didn't make actually a question, but I got the idea. So let me ask you actually a question, okay? And we're gonna develop our discussion from that one. Is it, or are there gems that we use for something different than, for example, jewelry? Are there gems that are technological
Diamond.
gems? Sorry?
The diamond?
Diamonds, for example, are a good idea, but we have other ones like ruby, even topaz, as you mentioned. But when you take a look at gems, and if you use this termination, okay, gems, they are not strategic, okay, for most of the countries, because what? You can go by without those, Okay, you can live without those. Nobody's going to die if you don't get your diamond ring. But nevertheless, for the countries which are producing those, definitely they are strategic. Okay, so if you take a look at Africa, they are definitely strategic to Africa. If you take a look at other countries who do the cut and the polishment of the gems, they are definitely strategic. But then again, let's take a look, or let's use a more technological approach to this subject, okay? So if you want to do a laser, if you want to make a Hubble telescope again, you're going to need lenses. And those lenses normally came from a single crystal, okay? They are monocrystalline. And you can do this synthetic, okay? But sometimes you just want to go to the nature and come back with some of those materials. Why? Because it's cheap, okay? For some stones, and I'm going to use the stone because we're talking about precious stones, sometimes it's cheaper, okay? And sometimes it is what you have on hand. It's going to be available to you. So definitely those materials, they are strategic, and for some applications, they are critical. One thing, on the other hand, that we can do is, again, make everything synthetic. From diamonds to opals, from diamonds to ruby, you can make everything synthetic. And that's why those materials are going down in our food chain, okay? So you're not gonna go to the USGS and find something like diamonds over there considered strategic or critical. They will be there, okay, because they take a look again about diamonds too, because in the United States, if you don't get your diamond ring, then your sponsor is going to be in trouble. They demand a lot of this. And just out of curiosity, I think this is quite funny, because I can only imagine one other animal who have similar behavior than people who desperately want a diamond ring. And do you know, guys, what other animal have similar behavior in the nature?
No idea.
Penguins. Penguins have similar behavior, because the male penguin, he take a look at the gravel, at the pebbles, I think it's a better word, pebbles on a beach, and he tried to find a more spherical pebble that he can, okay? So he's gonna take a look for days, even weeks, and he find the perfect pebble, okay? So he's gonna collect this pebble, and he's going to deliver this pebble to the female penguin, okay? So he came there and just dropped the pebble in front of her, okay? And if she likes it, they instantly a couple, okay? They got married, and they're gonna stay married for the whole life of the show. It's amazing, it's beautiful, okay? But they are penguins, for the God's sake. They're not human beings. Okay, so if you think that you're gonna receive a diamond ring and your life is going to be beautiful forever, you're thinking like a penguin. Okay, and yeah, it's beautiful. I love diamonds. It's one of the kind. Okay, and if you don't have this feeling about diamonds, just go online and see some videos, and you're gonna see how beautiful those stones are and how they interact with light. It is amazing. Okay, and if you don't have, or if you don't have yet a golden rush, oh, I don't care very much about gold, it's because you haven't been around gold. Okay, when you're around gold, and I mean it, like walking into a place full of gold, it's really, really beautiful. Okay, so when you go into the Grand Bazaar in Istanbul and you're down the aisle, and you're only about jewelry around you, and you see diamonds on your side and the other side only gold, 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 it's really a great experience. Okay, so I understand why people are so fixed on those kind of materials. I completely understand. But again, we're talking about the 21st century, and we have to move on from this kind of feelings. Okay, you don't need to have gold on you to be more than other people, things like that. Okay, to show how wealthy you are. It's not okay. It's just like have a huge car just to show off. Okay, it doesn't make sense anymore. Okay? Again, I'm not making a critic for people who think like that. I completely understand all mindsets, but in my opinion, that's a personal opinion. Okay, in my opinion, we should be moving away from this. Okay, I don't think this is sustainable. Okay, in the short version, I don't think this is sustainable. We don't have diamonds for everyone. Okay, we don't have gold for everyone. Even because we need gold inside machines like this. Okay, we need to use gold in satellites. Okay, we need gold for other things, and gold is restricted in our planet. Okay, so we don't have an open source for gold, and that's why I think we should be more careful about those. Okay, Thais, please go ahead.
Just a curiosity about technology. I attended in a CBMM talks about 2 years ago, and they considered itself more a technology company than a mining company, and because of the niobium, and I think that's very interesting for this. Is a huge company that it's more a technology company than a mining company.
Great, Thais. Thank you so much for this input. We're gonna come back to niobium many times during this subject, and even during this lecture, we're gonna come back to niobium too. But you're right, okay? And I think CBMM is a very good way to show you guys how things have to be done. Why? I love CBMM, of course. I love also Niobras. Right here, it's our major partner for research right now. Okay, and we have a very good relation with them. And I thank all of the guys from Niobras, which is part of the CMOC group for that. But coming back to CBMM, okay, they have this situation back in a few decades ago. We have niobium, okay? We have lots and lots and lots of niobium, okay? And we can produce niobium. But what are we going to do with all of those niobium? And they said, okay, we have to come with an idea. What are we going to do with this? Because they drill and they make an estimation and they can supply the world's demand of niobium for 150 years. Can you imagine this? No one have these numbers, okay? No mine company had numbers like this. And it's a Brazilian company. It's amazing. They can supply the world's demand just then alone, one supplier for 150 years. This is an amazing feature, and the Brazilians doesn't know about this, okay? They should, but they don't. Nevertheless, they have this problem. What are we gonna do with niobium? Can we do, I don't know, niobium pots, niobium pencils, niobium jewelry? What are we gonna do with niobium? We will have so much. And then they have this idea, okay, so let's do research. Okay, it's obvious. The answer is on research. Let's do basic research. What kind of compounds can I make with niobium? And after that, where can I apply those compounds? And that makes a lot of sense. That's the way to do it. Okay, and then they have this insight. Okay, let's drift away a little bit, just a little bit for a moment, for mining. Okay, we know how to do mine. Okay, it's okay. Mining, it's not a problem. It's going to be an open pit mine. It's quite simple. Extract the material, and this is not a problem, definitely. So let's go to mineral processing. Is mineral processing a problem? Yes, mineral processing was a problem because nobody did it. Okay, that is just them. You don't have anyone to talk about. Okay, you can't just take your best friend on the speed dial and say, "Oh, what are you doing with niobium over there?" Say, "Ah, that's okay. Just do this, and this, and use those collectors, and you're good to go." Okay, they didn't have anyone to talk about. They didn't have a benchmark, even to compare. Okay, so I have this recovery, and this is good. I don't know. Okay, you're alone. You have no one to talk about. And they did a very, very good job, okay? And they thrive from that. And I literally mean that, okay? They made an excellent job. And they start to develop products. And they said, okay, so we're more than a mining company. Just like Thais said, we're more than a mining company. So what we are, actually, I like to think they are a material science company. I think the best definition, it's my definition for CBMM is they are a material science company because they develop materials and they are focusing on developing materials. Of course, all of those materials take niobium in their formulation. Of course, they are on the niobium branch. okay? But nevertheless, they do materials, okay? And I was in a talk. I was a speaker, and they were also there. I think it was 2018. We were in the Brazilian consulate in Berlin, and I was talking about rare earth. Brazilians are rare earth, and there are many Brazilian companies over there, like VEG and other ones, and CBMM was there. And I was thinking, okay, they're going to talk about rare earth too. And I was surprised they went there not to talk about rare earth. Instead of that, they were talking about carbides, niobium carbides. Okay, quite amazing. Because when you talk about carbide you make for cutting tools. Okay, like this picture over here. If you take a look at this material over here, this could be a carbide. Okay, probably in this case is some steel alloy, like a hardened steel alloy. But you can do this made of carbides, okay? So if you want to make a pen to cut glass or things like that, you're gonna use carbide. If you're gonna make a drill for dentists, you're gonna go to carbides. You're moving away from diamonds and into carbides, okay? But then they came with this idea of niobium carbide, and it is amazing because it's really good, okay? The product is really good. And then during the talk, they came to me and said, okay, we want to do more with niobium. I said, of course, you always say this. And they have a prize, okay? They have a competition every year. If you have an idea or something to use niobium, they give you a good price, okay? It's very good price. But nevertheless, they want to do nowadays, it's going to sound strange, but hear me out. They want to replace copper in wires. Okay, they want to take out copper and they want to put niobium in super alloys. Okay, so we're talking about superconductive alloys. So instead of having a machine like a MRM machine or a computed tomography, and you use regular wires inside of it and you produce a lot of heat, you go to this titanium niobium alloy and you have superconductivity on room temperature. It is amazing. So you don't need to freeze the wire. Okay, so niobium is really important for us, guys. Really. And it's not on the floor. Okay, it's not in the floor. Things that our government consider important. It's quite important. Ramon, please go ahead.
Thank you. So I think they are using also niobium for produce hand sanitizer.
Yes.
And that was amazing when I saw the program. And another question: do you talk about strategic minerals? And I think if we talk about uranium, can we see it like I see it like a strategic mineral, but the countries don't produce it. They produce it more for themselves than sell for other countries. Is that also a kind of strategy minerals, political wise?
Yes, Ramon, thank you so much for bringing this new application of niobium. Definitely, I saw something coming from the Federal University of Minas Gerais. They performed these sanitizers made with niobium, and they can kill COVID-19. That would be an amazing feature for niobium. Again, I mentioned this last lecture, and I'm going to do this every time that we talk about niobium. I think the name of this element should be like Brazilian, because it's all about Brazil. And to summarize, if we in Brazil doesn't develop products made of niobium, who will do this for us? Okay, so it has to be made of us. Okay, it's just like when you take a look at Marvel and you see that amazing things come from Wakanda. because they have the mineral supply over there, so they have to do these things. Okay, they have the mineral, they have vibranium, so made everything out of vibranium. So we have niobium. I think we should be driving niobium cars, niobium watches, and everything, because niobium is here. Okay, so when people come to Brazil, what they buy? Havaianas. Of course, they want to buy Havaianas because we produce Havaianas. It's something that you instantly relate to Brazil. And guys, I have to tell you something. If you move to Europe and you try to buy an Havaianas, be prepared to pay something like 50 up to 60 euros in one Havaiana. And when I was young, Havaianas was like, oh my God, you can buy another flip-flop, so buy Havaianas, because literally, it doesn't have any market value. Literally, it would be something like that. Okay, and nowadays Havaianas are cool, are nice, and I love those. Okay, I'm not saying anything bad about Havaianas. I'm just trying to tell you that Havaianas is all around the world because it's a Brazilian brand. Okay, so if we can do this with flip-flops, imagine with niobium. Okay, we have a huge potential. So niobium is critical, it's technological, and definitely should be strategic to Brazil. So going to uranium, we do have uranium, cerium, thorium in Brazil. We have right here where I'm talking with you in Catalan. And uranium, it has a bad reputation. Okay, so people doesn't want to talk about it because, oh, okay, it's dirty and we should be moving away from this. But I think we need something like technology to fill the gaps. What I want to tell you with this, Ramon, is something like that, okay? I want to see the world being 100% supplied by solar energy, okay? So that's my goal. I want to be alive to see this, okay? On the other hand, nowadays, we're not there, okay? We're far from that, okay? We're still using fuel derived from fossil, okay? So fossil fuels. What we're gonna have in the middle, okay? What is the technology who's going to fill the gap? Can we jump from now to the future without this gap technology? If the word is yes, so that's great, okay? So we just combine, we merge these two, and we instantly go from point A to point B. But if you can't do this, like this machine that you're seeing over here, okay? Look at the size of this truck, and look at the size of this transformer right over here, because this looks like a Michael Bay's movie, okay? It's like a transformer. And of course, it's a Russian machine. It has everything Russian on it, okay? It's beautiful, it's big, it's like a Titan. Colossal machine. But nevertheless, how I'm going to supply energy for this machine? Should I plug a cable on it and deliver directly electricity to it? Sure, so let's do it, okay? It's impossible. Imagine the size of the cable, and imagine how limited the movement of this machine will be with a cable attached to it, okay? You can't do much. Okay, so let's do different. Let's put engines inside of it, and these engines are going to convert diesel to electricity. Okay, so we come back to stage A in our evolution, okay? I want to be stage B. Should I put a lot of solar panels on top of it and it's going to be sustainable? No, we can't do this. But what's going to be the middle technology? What's going to be the gap technology? Okay, and I, for once, think that nuclear energy would fill the gap. Okay, that was my position a few years ago. Now I think helium-3 could be the gap technology. But I don't know. One thing that I know for sure is we need to develop gap technologies. We need to move from point A to point B, but we're going to have like a point C in the middle. So we're going to exit this phase. Okay, this stage is done. We don't have this anymore. Now we're here, but our focus, our target is to get here. Okay, and let's do this step by step. Okay, so if you take a look at Europe right now, you can find like a bus around the city, 100% electric. Okay? It's normal. You can find subway tubes, electric also, yeah, fine. Okay, so we're going slowly, but we're going to get there. Okay, and if you take a look at uranium and thorium, I think they are important, not only for submarines. Definitely for submarines, you need uranium, but for go up, okay, we need electricity up there, okay, and if you're going to put a station in the moon, you're definitely going to need uranium to supply your electricity. And what I think is, to summarize, Ramon, I don't think we should just take a technology and throw it away. Like, oh, I don't want fossil fuels anymore, just throw it away. I don't want uranium anymore, throw it away. Why not carry on research on that also? Okay, and said, oh, now I can produce electricity out of uranium in a more safe way. Oh, that's nice, because we still produce electricity using uranium. So let's do this now, this 2.0, okay? And during this test, I can produce a 3.0, 4.0, and so on, okay? So what I don't think it's okay is just to throw away technologies. Okay? I don't think that's the way to do it. Sometimes you need old school technology. It's good to know that you can improve everything, okay? Because you never know what's going to be the gap technology. Okay? We have this idea, and normally we fix it in one thing, but then you just throw away good stuff. Okay, and if I can give you a very good example, I like Westerns. I really like Westerns. Just to sit down and see an old Western, like 50, okay, coming from the 50s. And I was impressed. I was literally like, wow, like a child when I saw my first Western on Blu-ray. Okay, a Blu-ray Western coming from the 50s. It's something. Because when you take a look at these movies, they are shot using very old cameras, okay? And back in the time, it was all black and white. Everything was black and white. And the sound was like mono. We didn't have stereo. We didn't have a 7.1 sound, surround sound in the 70s. Forget about it. But then again, the technology that they used to shot the movies, they are analogic, okay? So they have huge information on that silver crystals. So time went by. The problem back in the time was not to shoot, okay, but definitely the problem was to reproduce the movie. The TV was crap, okay? But nowadays, our TV is full HD. Can you imagine this? We have a full HD TV. I look now to my screen, and it's pretty much the same thing that I look at you face to face. Of course, it's 2D, except for the fact that it's 2D image. Okay, I don't have goggles for 3D immersion. It's 2D. Beside that, it's the same thing that look into your face. And now we take back those crystals. Okay, we took back those shots from the 50s, and color is there. You can see color. And you can see brighter colors than you can see nowadays using CCD cameras, which means that the camera that I'm using right here to broadcast to you, and it's written on that camera, HD, okay, it doesn't have the capability to capture color as well as a movie shot in the 50s. This is amazing. Definitely, this is amazing. So that's why I'm giving you this explanation. Don't throw away technology, okay? Because eventually you're gonna need it. It's just like math. Many equations were developed 100 years ago and doesn't have a use, but maybe the equation that you're searching for is that one. And then you're gonna find a use for this equation. And then you're gonna say, oh, now I understand why that crazy guy performed this equation 100 years ago, is to solve this problem that I didn't have 100 years ago, but now I do. And the equation is there because we're talking about tools. Okay, eventually we're talking about tools. So niobium for CBMM is not a product anymore, it's a tool. Okay, it's a tool to achieve other things. And that's why I strongly believe that CBMM is not a mining company only, okay, but it's more like a material company. because they are focusing on developing new materials based on niobium. And that's the Apple way to do it. Okay, that's the Apple way to do it. And I strongly believe that CBMM is in the right path. And I think many other companies could learn from that. Okay, they should be learning from that. What should I be doing with my aluminum, titanium, iron, gold, in order to be a better player in this market? Okay, guys. But again, those are just some insights and some ideas from a crazy guy. Okay. Any other question? Mateus just sent me a question. It's so high-tech class. Just type the question. So I'm going to read for you guys, okay? Maybe strategic or critical minerals, even those not produced in the country. Sure, definitely. One thing that we should learn from a guy right here from our age called Sun Tzu. Okay, Sun Tzu is not from our age, but his book is amazing. It's The Art of the War. It's not only that saying in the peace, prepare for the war, but it is keep an eye on your enemy. Okay, in this case, I mean keep an eye on your supply. Okay, Mateus, if there is something that you guys as engineers should be studying and studying hard, it's about industrial engineering. Okay, I mean it. Take a look at this. Not only quality control, not only quality tools, but about supply chain. Okay, so if you're a mining engineer, you need to know about supply chain. Why? Because you're in the fringe of the supply chain. Okay, you are the first stage, almost the first stage of supply chain. Okay? And you have to know about this. So if you're a supplier, you need to know all of other suppliers, all the other players. Okay, if you're buying something from someone, you need to know every single one who can sell to you this equipment or this material or this ore. Okay, because you can actually have a better and broader view or where or to when you're going to pass on your money. Okay, so yeah, and one thing that we have to consider also is this regarding niobium, because Brazil has a bless. We have almost all niobium of the world. On the other hand, this is a curse. Okay, definitely this is a curse, because people are afraid to use niobium, and they're afraid that someone's going to come and say, oh, okay, you know that Brazilian niobium, it doesn't belong anymore to this or that company. It belongs to the Brazil. And now I'm going to put the price as I want to. Okay, so people are really, really afraid to have this kind of strategic adopted in Brazil. Okay, I'm the supplier, I'm the solo supplier, I'm gonna triple the price of niobium from now on. And if you wanna have niobium, you have to pay the price. If you don't want to pay the price, you don't have niobium, that's all. And I'm gonna show you guys that China did this with rare earth. Okay, so this is not thing coming from sci-fi fiction. This is actually true. Some countries do this with oil, crude oil, petroleum. Okay, they do this with rare earth. They do this with gems, like diamonds. So we have many, many examples of mineral commodities being used as cheap bargain. Okay, we're gonna do this with you guys. So that's why people are afraid of using niobium. And you have replacements for niobium. And I'm talking about steel making companies. Okay, they can use niobium as a micro alloy agent, but they can use also vanadium, chromium. And if you go to a hardware store, I love hardware store, and if you buy a tool, I can show you later on tools made like this. I have something around me. Oh, I can take one right here. So if you have tools like this, okay, like screwdrivers, this one is like a regular one. It's called a Power Fix. Doesn't have any brand on it. So this is, it's called a premium, but it's no premium at all. It's a cheap one. Okay, you can see a regular steel. It's made of regular steel. Okay, nothing special. But if you go to tools like this is a Geodor one. Okay, and I'm gonna make a good publicity for Geodor. It's very good tools. Okay, this is of course more expensive, but if you take a look at, I'm not sure if my camera can broadcast this, but if you take a look at the steel, you can see that this one is like a polished steel. It's more regular, and this one has like flakes on it. Okay, and you can see that my tools are a little bit magnetized. That's on purpose. It's not like a side effect of the steel or anything like that, but this is vanadium steel. And when you take a look, this is ugly. It's not so shiny like this one, but this has a mechanical strength really, really higher than this one. Okay, this is a better tool, and you're gonna pay what, like $5? $5 for this one, and $2 for this one, $3 for this one. Could I make these same tools out of niobium? Definitely. I can change the vanadium inside of the steel of this one to niobium. Okay, and what we're gonna have with this? A better tool. And I don't have one single tool made of niobium, not one. Okay, I have my car definitely, but that doesn't count. Okay, we have niobium on cars, but I'd like very much to go to the hardware store and said, okay, how much is the niobium one? $7. I pay $2 extra to have a screwdriver like this, okay, made of niobium, because it worked. When I'm gonna put strength on this and apply torque on this one, if I have a niobium one, I would trust more on my niobium tool instead of a chromium vanadium one like this one. And I'm not talking about Geodor. Again, these guys are top, okay? At least in Brazil, they're top of the line. But I'm talking about the alloy itself, okay? And definitely, the niobium alloy would overmatch this one. Okay, so you're right, Matheus. We have to take a look not only on what we can provide, but what we want to have. Okay, what do we need? And that's why United States take a look at 90 different compounds. Okay, not one, but two, 90. It's amazing. Any other questions or comments? Please go ahead. No? Okay, so let's keep going. So I made this chart just for you to take a look a little bit of what United States are dealing with. And we have quartz, rare earth, manganese, phosphate, niobium, aluminum, bauxite. Aluminum and bauxite are connected, but they are separate over USGS, copper, iron ore, graphite, gold, and so on. The size of the words normally means the repetition of the words. Okay, in this case, it doesn't mean that. Okay? I put the words bigger, or I increase the size of the words just to make this effect. Okay, so if you go to USGS, that's not correlated with this. For example, palladium, I put a very small word. Okay, that's because we don't have palladium produced in Brazil right now. Okay, the biggest one we have in Brazil. So that's why you have big words and small words. Okay, but we have all of those produced in Brazil, and they are quite important for us. Again, another beautiful chart. I think this chart is really, really clever. Okay, and I suggest you guys to take a look at the slides. I'm going to send all the slides to you. Again, this lecture is going to be fully available on my YouTube channel, and also the slides are going to be there. Okay, just click and download it. And as you can see on the right-hand side, on the bottom of the slide, you can also click and go directly to the source of this chart. Okay, and this comes from the EU community. Okay, and what do we have over here? That's the idea of the EU for supply risk of raw materials. Listen up, for key technologies. See, Matheus, how these guys are clever. Key technologies. So it's all about technology. And now we have key technology. So let's consider something. What is a key technology? Battery. Battery is key technology. Everything now runs on battery. Okay. Fuel cells. Okay, again, fuel cells, we're talking about a different kind of batteries, but nevertheless, batteries. Another thing, motors. Okay, I want to produce better engines. And when you talk about engine, we're thinking about combustion engine. So let's keep that out, okay, and let's focus on motors, electrical motors. Wind turbine. Another key technology. All the world nowadays assumes that wind turbine is one of the best ways to do it. The other way to do it, PV, photovoltaic electricity. We just say PV. Another thing quite important for the world, robotics. Robotics are amazing because you can nowadays run a complete industry without people or with less people than before. So we go on with robotics. They do better, they do repetition, and they are quite precise. We're not, okay? Drones, another different kind of robotics, but it's also important to us. Amazon are delivering your package right now in the United States using drones. Okay? So you don't do anything. You just go online, you order, and the drone land in front of your house. It's completely safe, completely safe. It's without any kind of contact with human beings, and you don't need to worry about the people who's going to deliver your food or deliver your merchandise, to also put yourself in risk of contamination of any sort. Okay, it's great. And it's silent. It's another thing that's quite interesting. It's silent. And another thing, 3DP and also ICT. So as you can see by the charts, when I talk about ICT, we're talking about processors. We're talking about the main core of anything that is electronic. Well, on the bottom part, what do we have? The chemicals or the elements and compounds that I need to have to do those key technologies. And the colors means the supply risk. So if you're in the green area, you're okay. Supply is not a problem, okay? But you need this. For example, lead. Lead is not a problem of supply, but for Brazil it is. For Brazil, it's definitely a problem because we don't have lead minings in Brazil. We don't mine lead, not anymore, okay? And then we have huge Brazilian companies and great companies who can produce batteries made of lead. And those guys produce batteries like Moura, and they put those batteries inside of new cars, Brazilian cars, not Brazilian cars. It's not very good to say that. A Brazilian-made car, okay? We don't have Brazilian cars anymore, unfortunately. I love Gurgel. Okay? It was a revolutionary guy. Gurgel was actually our revolutionary engineer, just like we have many others in the United States, etc. But he is like our Steve Jobs. But nevertheless, we don't have Brazilian cars anymore. So the Brazilian lead, it's sent outside, okay? It goes away with that car. So we need more lead. That chart would be completely different for Brazil, okay? But for the US, they have Spain, and Spain can provide lead, okay? So it's not a problem of supply risk, but it's good to take a look at this. But if you on the other hand, on the red zone, then you have a problem because you have a supply risk of those elements. And take a look at the first two. The first two elements or family of elements or compounds that they are most concerned are light and heavy rare earth elements. So this talk would be also about rare earth. We have to talk about rare earth. And then in orange, everything that you need to produce, among others, batteries like magnesium. Niobium is the fourth one. Take a look at this. Niobium is the fourth one. And in Germany, they have now a specialized company to recycle niobium. Niobium is now a recycled material in Germany. It's quite nice. Germanium, phosphorus. Okay, phosphorus is important too. Santiago, please go ahead. Make your contribution.
And teacher, I have a question. According to you, do you believe that any country, in this case Brazil, is prepared for a time when an element is scarce? For example, niobium.
No, I think it's the opposite. I think no country is prepared for this, and you can take a look at what happened during 2020 when we have shortage of everything. Okay, so okay, Santiago, now I'm gonna try to walk in a path that is a quite dangerous one. Okay, I'm gonna try to tell you about supply and demand in the new world. And if you take a look on how we're living in 2018, 19, let's consider 2019 for a moment. 2019 is a good idea. everything was globalized. Okay, so if you want to buy on webcam, you just order and you wait a few days and it's going to arrive for you right from China. Okay, that's great. If you want something extra like peach, you order and it's come to you right from Chile. If you're in Europe, everything you eat comes from another country, probably, okay, and even from another, not country, but another continent. Okay, I was in Germany. I lived there for 1 year, and I hated the bananas. I hate it because I'm from Brazil. We have many kinds of bananas. So when I walked into the supermarket, there was one type of banana, like a European banana. I said, "Oh my God, I hate those bananas. I'm so hungry for bananas, and I can't have like the only one banana." So it's quite interesting. When you go to the supermarket, say, "Okay, buy bananas." I said, don't need to ask which one. There's only one type of banana because everything is standardized. So you have one banana. And the same happens with grapes. They have just like one kind, like different colors, but one type of grape. And I took those grapes, it was written Brazilian grapes. I said, okay, I don't think those are Brazilian, but yeah, okay, let's take those home. What I mean is, it was okay to depend on other people, okay? That's how the world was running. But then COVID-19 came and we have shortage of everything because our partner couldn't deliver. And I'm not talking only about grapes or bananas, but I'm talking about ore. I'm talking about rare earth. I'm talking about phosphorus. I said, okay, we have a problem. And we have a huge problem because we're so used to have peace, so used that we didn't consider to have a war. And now we're facing like a bio war. And we're not killing each other, but we're all dying. Okay? Who's going to supply us? Okay, you should be supplying yourself. So you said that all countries, no, I think no country is prepared to this. I think some countries have more abundance of some material and they can supply itself. Like Brazil, we can supply our niobium, definitely. For example, here in Catalan, the city that I live, we produce niobium. We're the second largest niobium producer in the world, out of 3, but we're the second largest, okay? And the first one, CBMM, they produce like 93% of the niobium in the world, and the other market share, 7%, we produce something like 4 up to 5%, okay? So that's the difference, that's the gap between the second one and the first one. Everything, okay? But yeah, 93.5. And 100% of our production, 100% is exportation. So we don't supply the Brazilian demand. It's 100% exportation. And during the last year, we have problems to deliver niobium, okay? So now people are taking a look at this and said, okay, it's good to buy, okay? Because if you have niobium and I don't, I'm gonna buy from you. But I have things in here too. Okay, I could produce lead, for example, gold. I know that my gold production is going to be not cheaper, but way more expensive than yours. But maybe it's good to have this gold production, okay? And I'm gonna even try to support this gold production because if I have a shortage of gold, I can supply my demand. I have gold right here. And to be more specific, Brazil have a huge demand on phosphorus, huge, because we are an agriculture country. Okay, in Brazil, have even advice on TV, on open TV. So commercials, you're watching TV, and out of the blue, come an agro commercial, and it's coming from our government, and they say like, agro is pop, agro is good, agro is the future. We don't have anything like this for mining. Okay. Before you ask or you consider, we don't have. And actually, we don't have this for many other things, but for agro industry, we have. And if you want to have huge crops, and I'm talking literally about super crops, you need, in Brazil, to have lime, because our soil pH is acid, so you have to correct this. You have to have fertilizers, and I'm talking about chemical fertilizers. And you have to have different seeds, okay, specialized seeds. So those seeds you produce on labs, okay? And many companies can do this. You also need pesticide. We use lots and lots of pesticide, but you can do this also on lab. But you need mining for the line. And we have plenty of mining companies in Brazil right now, small ones, and they are supplying those. And they are scattered around all of the Brazil. Okay, so you have this, but you don't have phosphorus all around Brazil. Okay, you have some places where you can actually mine phosphorus. And that's why phosphorus appears on this chart too, because you need to eat. Okay, and if you need to eat, you need chemical fertilizers. In Brazil, we have Cajati, Catalão, and our neighbor city, it's called Ouvidor. Actually, the mines stay in Ouvidor. They are not in Catalão itself, but they're in Ouvidor. But we have Tapira, we have Patos de Minas, we have places where we can produce phosphorus, but not a lot of those. And one thing that is interesting is when you take a look at phosphorus, Brazil is a different kind of phosphorus. We use igneous phosphorus. Our phosphorus comes back from the volcanic activities. And if you take a look at Morocco is the largest producer of phosphorus in the world. They are sedimentary ones. And you have other places in Africa who have this potential to produce phosphorus coming from sedimentary sources. And that's great because you don't need mineral processing. You just need to grind, to sieve, and you're ready to go. Okay. But in Brazil, we need grinding, sieving, and flotation. You need to float this material. And that's why our cost is higher. Okay. But nevertheless, we can supply 54% of the Brazilian demand on phosphorus. Just 54. And of course, you don't use phosphorus only for agriculture. You use phosphorus, for example, to feed animals. Okay, there are other applications, but we can only supply 54. And we have, I think it was 2 presidents before. We have a visit here in Catalão of the president. He came here and said, okay, what do you guys need to produce more phosphorus? And we said, okay, do you want the whole list? Really? Do you want the list? We can do this. Okay, if you said, okay, produce now 100% of our demand, go. We can do this. But then you have to consider something. A mine has a life. Okay, you have a lifetime. And the lifespan of the mines in Catalão is now 20 years. Only 20 years. So if you double the production, we're gonna run enough ore in 10 years. So I'm gonna have to close the mine in 10 years. Can you imagine the result of this for this community? Because if I want to double the production, I have to double the number of people working the mine. I have to double the number of trucks hauling ore. I have to double the number of mineral processing plants. I have to double everything. And after 10 years, I have double of a lot of things and I don't know where I'm gonna use those things because I'm running out of ore, okay? And we have ore for more than 20 years, but we don't have technology to do with that ore after 20 years. That's our problem today. Our flotation only works for 20 years. After that, we need new chemicals, new process. So we're now racing against time in Brazil regarding phosphorus. We need to find a way to separate phosphorus, and I'm talking about apatite. The mineral is apatite, okay? It's a calcium phosphate. From, on the other hand, calcium carbonate and magnesium carbonate too, because we're sitting now on alkaline complex. Okay, so we have apatite, but we have also these alkaline minerals. And if you consider what we're doing now, we use a technology developed in Brazil in the 70s. We use fatty acids to flotate those minerals, to flotate apatite family minerals. But those fatty acids also floated the carbonates. They go together because my collector only see calcium. Okay, my collector is not selected regarding calcium. So everything that is calcium on it floats. Okay, and we have to develop new chemicals. So we need more research. In order to our government come to us and said, okay, double the production. It should be considering this, double the number of researchers. let's research more, because if we research more, then we can double the production. But before that, it's pointless. It's like a dead end. Now I'm going to produce more, but in 10 years, I'm going to produce 0% of the Brazilian demand. 0. In Catalão, in Ouvidor, we supply something around 20% of the Brazilians' demand. Okay, so we are a major player. Together with Tapira, Araxá, Cajati, we are a major player. So if you take us out of this equation, you're in a problem. Okay, because you're going to have to buy more from other countries like China, Morocco, Africa, in general. And are those guys willing to supply you more phosphate? Okay, how about the prices? Do you understand now, Mateus? So everything is about what I need, what I'm willing to pay for, and from whom. Okay, and we have to consider this. But it's a very good discussion, right? It's important discussion for us. Okay, if you have any questions, let me know. So let me go a little bit further in here. Okay, as I mentioned to you before, rare earth. Two first for Europe are rare earth. They are eager to have more rare earth. And that's why we have 2 projects in collaboration with Germany, only focusing on light rare earth. We don't have here in Catalão heavy rare earth. Okay, I'm gonna come back to rare earth in a few minutes. And then come to this chart. And this chart is, again, impressive. Why this chart is so impressive? Because here you can see what Europe's need and who can supply. Okay, the chart before is what we need. Now is who can supply. And then you see that the United States is a mining country, and they have 90% of the beryllium source in the world. They can provide 90% of the world demands, and they can provide helium. Okay, helium is quite important. If you talk about medicine and medicine equipment, you need helium. Okay, Russia can provide palladium, but palladium we always think about South Africa. Okay, it's amazing. The PGM minerals comes from South Africa. Okay, and during the time, South Africa was like first world, and they were producing what? PGM. So back in the time, people, back in the time, when Stan Lee was really on it and writing comic books, they came to South Africa. The idea of vibranium came from South Africa. And he came and said, okay, but South Africa, these guys are great, they are big. Let me take something small, because everybody's going to know, okay, that guy made all of something like platinum. Everybody's going to say, okay, you're talking about South Africa, and we already have silver sulfur. Okay, so let's do something different. Okay, what do we have in Africa that nobody's paying a lot of attention right now? So, okay, we have tantalum. Tantalum is not so nice, but we have columbite tantalite. And they call this like 2 names. They took like columbite and tantalite. They said like coltan. Oh, coltan is a powerful name. It's quite nice. But I like that one in the end. So let's talk about vibranium. And Rwanda becomes Wakanda. It's quite interesting, right? I can't say Rwanda, so I'm going to say Wakanda. That's one of the explanations. But Rwanda can provide 31% of the world's tantalum. Okay, and Congo, they can provide 64% of the cobalt. And take a look at Europe. They supply nothing. Okay, just France, who has hafnium. They have a lot of hafnium. But niobium comes from Brazil, 90%. But now take a look at China. And you're going to understand a little bit why China is important. Because they supply lots of things. Okay, they supply lots of a lot of things. And China is by far the most important mining country in the world. Okay, by far. So every time that you talk about mining, you have to consider China. Okay, they are quite important. They know it. Okay, that's the most important thing. They know it. So if you take a look, it's like 1980, 1980. So that's why you have to be friends with China. Okay, please don't be a Chinese enemy right now, because they can provide almost everything that you need for this chart. Okay. So coming back to Brazil, which is our study object, what is important to Brazil in that strategic plan up to 4 years? I don't know about you guys, but I think everything that is strategic and is technological should be like 6 months. Okay, what is strategic for this country for the next 6 months? 4 years is a lifetime. Okay, do you have a phone that is more than 4 years old? So you're not on the technology. Okay, so if you're on technology, it should be like 6 months, 1 year tops. So definitely, that's the Brazilian definition of strategic. So we go to light and heavy rare earth in general, phosphorus. We skip niobium. We put niobium out of the list. Nevertheless, lithium and silicon. If you take a look at this, silicon is not a problem for Europe. It's not a problem for supply. Okay, it's okay. It's irregular. Okay, lithium the same. So we focus on only 4, and are not the 4 demands or high demands for Europe, or for United States, or for China. So who actually wants to take a look at this material? That's a question for you guys to think and answer me later on. Okay. Nevertheless, let's keep on. Another nice chart from the EU, and this chart you can see now supply risk versus economic importance. Okay, and who is on the top? Rare earth. Okay, so rare earth, it's actually economic important for human beings. Okay, not for EU. And on the other hand, has supply risk. Okay, niobium is right here, and phosphorus too. So when you take a look at this chart, you can understand a little bit better the Brazilian choices for strategic minerals. Okay, probably they look only on this kind of chart. And this chart is from 2020. Again, Brazilian did that document on 2017. Okay, so 3 years before. So actually, our Brazilian researchers, they are not so wrong. Okay, they were in the right path. Okay, in the right direction, but they left things behind. That's the important thing, because if you take a look, barite is in here. Okay, barite, it's here. Take a look here. We produce barite here in Catalão. Okay, and it's a co-product, and from time to time we just throw it away because there's no market. Can you imagine this? There's no market. Bauxite is right here, and it's out of the Brazilian plan. Graphite, it's in here. We can produce this. PGMs, we can produce. That's why we don't take a look. Cobalt, we're not producing. It's here. It's scandium, borite, germanium. Magnesium, we can produce. It's right here. Okay, so why not take a look? So again, we've seen a lot of lithium movement in Brazil. Okay, but we can produce vanadium. It's here. Titanium is here. Silicon, it's here. Okay, oh, silicon is there too. Yeah, but as now you can see a little bit more why people choose one instead of the other. I think we should consider more. Okay, to summarize and to give you a huge spoiler, what is the end of my presentation? We should expand our vision about critical and strategic minerals in Brazil. Okay, with very short vision. Okay, very narrow vision. Again, another beautiful chart from the EU, and I think this summarizes everything. On the left-hand side, you have the supply risk. Okay, so again, in colors, red, very high risk, green, very low risk. On the right-hand side, you have the key technologies, and they group now by 3. Okay, renewables, e-mobility, and defense and space. Look, for the first time, I'm talking about space with you guys. And in the middle, we have those technologies that we saw before, now again presented in the middle. Okay, and normally, people, when you put something in the middle of a chart, is where you want the attention goes to. Okay, so I want you guys to focus on the middle, and then you can see the branches going from one to the other, and like a lot of branches, but you can see that you need pretty much everything from your left to get you to the right. Okay, and that's why it's a very beautiful, very beautiful chart. And this is actually the front cover of the critical raw materials for strategic technologies and sectors publication from last year. Okay, so this is the cover. So right there. Again, quite important for us to take a look. And I mentioned drone before, and sometimes we only think about drones to deliver package, and that's not the case. Okay? Again, we think about drones also for grown-up children to be flying around and taking pictures or doing nothing besides having fun. But we do drones for geophysics. We use drones for taking a look if our trucks are completely loaded or not, if the roads are okay or not. So in the future, I strongly believe that we're going to get to a mine, for example, and you're going to see a swarm of drones around, every drone doing something different. For example, taking a look if we have stabilities on our mine in general, if we have stability around our roads, if you need to water the road or not, if you have dust around. So the drone is going to be doing this, okay, and to deliver you an online feed of everything, okay, including camera. You don't need anymore to install a video camera. You just fly your drone. It can do everything, even collect samples. Why not? Okay, you go there in front of a mine front and you collect a small sample and bring it back. I'm going to analyze this for you. Just do this. Okay, go to a slope, collect a small sample, come back. And one thing that we also have to consider, and I think Mateus was doing this very, very good explanation about this or insight about this, and Ramon also did the same. It's about geographic availability. So if you're living, for example, in China, your geography and your geology is a blessing. So you have pretty much everything, but you don't have niobium, okay? And you have a shortage in iron ore. And then you have to consider, okay, I have many things that are critical for me because I can produce, but I don't have iron ore. And iron ore is critical for me because I'm China and I'm the largest producer of steel in the world. And on the other hand, I'm the largest consumer of steel. Okay? I produce half of the steel in the world, and I consume more than half of the steel in all the world. So yes, iron ore for me is critical. But for my neighbor, it's not. Okay, so yes, geography is everything. Okay, and geography means also culture. When someone asked me, I think it was Diane, about gems, we export some quite strange gems to China. Okay, we export quartz to China with rutile. Rutile is titanium dioxide. And if you have this quartz crystal and you have rutile inside, you're going to see rutile coming like needles inside of it. And what they do with this? Nothing. They just put on the table and they pray. Okay, for them, that's kind of stone that brings energy, that brings peace. So for them, it's important. And they like to have those around. So they buy it. Okay, so it is strategic to Brazil. Yes, it's strategic to sell everything for China, because if you sell things to them, they sell things to you. Okay, so yes, definitely strategic. Not from the point of view of making profit, but to keep your partner in business happy. Okay, so yes, definitely. It is critical. No, it's not critical. Definitely it's not critical. But there's a huge but. But if China comes to you and said, okay, do you know that kind of rocks that I like, that it's transparent one with something yellow inside? Okay, yeah, no. If you stop selling me this, I stop selling you hard drives. I'm going to stop to selling you computers. I said, okay, remove that thing to critical now. Okay, it's not only strategic, it's critical. Let's upgrade quartz crystals with rutile needles inside of it to critical. Why? Because I have a very good relation with my business partner, just because of that. Okay, so yes, guys, it's not only about a material thing, it's not only about a geographic thing or a geological thing, it's also about the political point of view. Okay, you have to be considering the politics. Okay, it is strategic to sell this to whom? To United States or to China? Sometimes you have to choose one of the two. Okay, and that's why, for example, in Brazil, again, we have two mines producing niobium. One is Brazilian company, CBMM. We're going to talk about these guys over and over and over again. And the second one was, at the beginning, okay, of my staying here in Catalão, they're coming from South Africa. It was belonged to Anglo America. They didn't started the niobium production here, but when I moved here 11 years ago, they were here producing niobium. And then they said, okay, I will not focus on niobium anymore. We're gonna go back to gold. So let's sell this company. And they sold this to a Chinese group. Okay, so here in Catalão, we're the second largest niobium producer in the world, and they belong to China. Okay, so now we're part of CMOG, China Molybdenum Group. Okay, so again, you have to be careful with your partners, and careful, I mean, you have to give them in order to give from to receive from that. Okay. Oh, let's take a look at Brazil. Okay, and those are the minerals that IBRAN think are, or elements that IBRAN think that are good to take a look on that. Okay, good to monitor. As you can see, I'm very pleased to show this kind of graphics because Brazil have mines in all of the extension. Okay, so general mining should be maybe our country name. Okay, and not Brazil. For people who doesn't know about our name, our country name, Brazil was actually a tree. Okay, and Portuguese people used to love those trees because it's a very beautiful wood. Okay, you can make like furniture out of it, but you can also use this to dye clothes. And you just boil it and you dye, and you have a reddish color to your clothes, and it was quite nice. But then they decided, okay, let's baptize this all big chunk of rocks as Brazil, and I think they should be considered something like more mine related. Of course, I'm mining engineering, but nevertheless, look at this. We don't have this tree, Brazil, pau Brazil, like Brazilian wood, all around our country, but we do have mines all around the country. And as you can see over here, part of those mines are strategic to the world, okay, and also critical to the world. And some places that we can actually take a look and say, wow, this is important, like Minas Gerais, Pará, Goiás, Bahia, they are all here, okay? And those are just the tip of iceberg regarding mining in Brazil. Why IBRAM performed this chart or made this chart? Because those are the more important elements regarding the market value, okay? And we have all around. So looking from a strategic point of view, okay, we have to have in our hands these two things. What is strategical and what is critical? Critical in Brazil are things that we need to prosper, okay? Strategic things are things regarding defense, things regarding, for example, military use or policy use, but on the same time are things technological, okay? Elements where we can draw technological information out of this, or a very, very high amount of money. So we do have to take a look at strategy, okay? Strategy is important. So now we're gonna have a quick stop, okay? And I'm gonna come back to show you guys some minerals and elements around the world that are considered strategic and why. So I'm gonna show you guys some applications of those materials, okay? And again, we have to keep in mind that strategical for us is things that we can't go without. Okay? If I come to you guys and said, oh, what is strategical in your country? You have to be able to reply to me, okay? So I'm gonna give you guys 30 minutes, okay? Now in my watch, 10 a.m., we're gonna come back 10:30. And I'm gonna finish my presentation, and I'm gonna ask you guys, and I want to listen from you. What is strategic for your country, okay? And if you're a Brazilian, try to take a look at something that is strategic that I didn't mention before, okay? And then why, okay? Is that clear? Can you understand what I want from you? I want you to take a look a little bit more of your own country. Well, Professor, I'm completely lost because I'm not sure what should be considered strategic. So go to the USGS page, okay? So go there, you're gonna see that it's quite simple to browse to the web page. It's really simple. And take a look at what is there, okay? Take a look. Oh, they are considering manganese. Oh, okay, do we have manganese in my country? Okay, what I produce? Probably we're gonna have something like a mining ministry, and they're gonna post some information over there. Take a look, okay? When I come back, again, I'm gonna finish this presentation, and I want to hear from you. And you're gonna see that it's really impressive. What do we have as similarities, and what do we have is completely different from one country to another. Why? Because it's going to be connected with our way of life, with our culture, okay? Just an example, I'm from Minas Gerais, and for us, it's quite important, something called pão de queijo, okay? Pão de queijo would be roughly translated, it shouldn't be, but could be translated like cheese bread, but it's not cheese bread, okay? If you go to the United States and order cheese bread, it's not the same thing, okay? But nevertheless, it's quite important to us. So if you consider this, the supply of the materials to make cheese bread, they are critical for people from Minas Gerais. We can't live by without it. And if you cut cheese, and if you cut coffee, then we have another revolution in our state, definitely. We're gonna have like an independent republic of coffee and pão de queijo, okay? But jokes apart, that's nothing entirely wrong, okay? So take a look at what you can't live without, and you're gonna see that you're gonna have mines of this material, okay? What you need to sell in order to survive, you're gonna have mines of those material. So the first mineral that I want to show you guys is perlite, which is quite different chemical composition. It's just platinum and arsenium. It has 43.44% of arsenium and amazing 56% of platinum on it. So this is the first PGM that I'm going to show you. And when you talk about PGM or platinum group minerals, we also think about prices, right? So for you to take a look, when we see this kind of chart, it's quite impressive. The price of rhodium, so 1 kilogram of rhodium reaches the price of $210,000, okay? So it is a lot. And at the end of 2019, it went down to 106,000. So you're gonna say, okay, I can see some fluctuations. The price tends to be almost the same, but is it really high price when compared to gold? What is the gold comparison? So this is the gold comparison. Everybody wants to discuss about gold price and things like that, but you can see that gold was half of the rhodium price at the end of 2019, and many things happened after 2019. We have the COVID situation, and nevertheless, we talk about 2 years ago. So I updated the price in 2020. As you can see, the rhodium prices went up to 279,000, okay? And gold, on the other hand, went up too, but only to 55,000. And in the same year, but 5 months later, rhodium price went up again to $459,000. Gold again went up, but only around 10%. So rhodium went up 100%, almost, and gold 10%. That's the difference. If you take a look at palladium, went up something like 10%, and platinum stays the same. Okay, platinum remains pretty much the same. And I update this on the 7th of July this year, and rhodium went up again, and this time 50%. So in a time frame of almost 1 year, the price of rhodium went from 279,000 up to $600,000. Okay, and gold went from 55 to 57. Okay, iridium also draws our attention. Okay, do you remember iPhone? I showed you iridium on the screen of iPhone's screen. So iridium went from 52 to 181, 300%. Okay, up. It's something, right? Ruthenium also 300% up. And then I was thinking to myself, okay, I give this lecture many times about prices of PGM, and every time I come with something different, something that would weigh 1 kilogram. I said, okay, if this item was made of rhodium, that's the amount of money you had in your hand, said, okay, but this joke is a little bit old. I have to come back with a different joke. And then I thought to myself, okay, how about this? Let us consider that we had 1 kilogram of rhodium right now in our hands. What you should buy with this 1 kilogram? And I said, okay, that's a good thing. What would cost something like $600,000? Okay, that's great. Because if you convert, we're talking about 3 million Brazilian reais. 3 million Brazilian reais is a very, very, very good house. Okay, you can buy a top house. Okay, but people in that age, they are not so into houses. Okay, so what else? And then there's SF90. And this baby costs 1 kilogram of rhodium. Okay, so with 1 kilogram, only 1 kilogram, you can buy this tech beauty. Okay, and that's one of the top Ferraris in the world nowadays. Okay, it's brand new, of course. And then consider just one thing: how many different elements they use to make this? How many different compounds? How much technology do we have embarked in this marvelous of the technology? Even more, how much energy was expended in order to produce this? It is a lot. Definitely, it is a lot. And this value, it's only 1 kilogram of rhodium. So I think with that comparison, it's crystal clear to everyone that rhodium is a good market. Okay, so if you sell rhodium, it would be very, very good. So that's the Stratadel or Ferrari SF90. And it goes beyond imagination. So think about rhodium taking you beyond imagination. Okay, I think it's a good comparison what you can do with 1 kilogram. And what is the problem? The problem is we don't have a lot of rhodium in our planet, not country, planet. And that's why people, agencies like NASA and the European Space Agency, Luxembourg Space Agency, China Space Agency, they are really, really considering space mining. Okay, and that's nothing that we're gonna talk about sci-fi. Okay, no, it is so real that this rock, this is the Psyche. It's a meteor. It's an asteroid. This one is an asteroid, and it's one of the many NEO or NEO, near Earth objects, and we're gonna mine it. Okay, and when we're gonna mine it? Next year. And you can see the whole news right below when you can see the link to this news. It's a NASA permanent link. And the title of this story, it's quite funny. It's what is written on your top right, left-hand side. It goes like this: it's another space rock, or is it? So instead of using the word or, they use or, connected to the mine. Okay, so they are looking now to this space research as or. Okay, or, and we really considering to mine it, and we already did it. If you consider that we land a probe in a body, in a celestial body, and collect a sample and bring it back to analyze, it's already mining. Okay, it's not geological survey anymore, because we do have geophysics of many bodies. Okay, and we know for sure that there is wealthy over there, and that's the next step. We're gonna mine it, especially for countries who doesn't want to do this work in their own backyards, or for two countries who doesn't have the capabilities to do this. And by capabilities, I mean research. Okay, so Luxembourg is one of those, and they are really considering space mining. And that's why my lectures is going to finish with space mining. Okay, and we're gonna talk a little bit about mineral processing up there. Okay, not only here. So the next lecture, we're going to start to talking about mineral processing itself. But now we have some background. We know what are the mining stages. We roughly know about the complexity of producing ores because they can be strategic, they can be critical, and so on. And now we're going to start to take a look at the processing itself. But in the end, we're going to go up there in order to provide us with all the elements that we need, not only to survive, but to keep moving forward. And that's the idea. Keep moving forward. Of course, in a more sustainable way, but in a way. Okay. So I'm not going to talk about space mining today, but in the future, we will. So talking about the PGMs, rhodium is the first one. Why? Because it's so expensive. Okay. And what do we need rhodium for? First of all, for catalytic conversion. Okay. So if you have a car and you need to reduce nitrogen, you need to have a catalytic converter. Okay, and rhodium kicks in, and you can do more than that. For example, I'm going to show you guys from now on many beautiful things. Forget about the penguin jokes in the beginning with 2 diamond rings, and you can see on your left hand side a regular diamond ring. But if you coat it with just a small amount of rhodium, you get the ring on your right hand side. And it's amazing how rhodium can change everything. And it's a alloying agent. So even combined with gold or even with silver gold, that's the result that you have. Okay. So one thing that is incredible is the amount of rhodium that we produce every year. Just remember, 1 kilogram, 1 Ferrari. Okay. Top Ferrari. We produce 30 tons. 30 tons, 1 ton, 1,000 kilograms. So we're talking pretty much about 30,000 Ferraris per year. Ferrari can't produce 30,000 units, okay? But that's the amount of rhodium that we're producing. So yes, rhodium is important, it's technological, it's critical, and it's limited supply, okay? And we have abundance of rhodium up there, okay? Keep that in mind. So moving on, iridium. Iridium is one of the few elements on our periodic table that we can definitely say it's an alien element. Okay, we can't trace the source of iridium in the planet Earth. Okay, and literally in the planet, not on, in the planet, inside of the planet, we can't understand how iridium is formed. So the idea right now is meteorites hitting Earth, bearing iridium with them. Okay, so we need iridium, and electronics needs iridium. And one thing that is amazing is it's literally or virtually immune to corrosion. There is no corrosion related to iridium. So when you mix it with osmium, you can produce alloys that you can use for many things. For example, you can replace titanium in the point of your pen with this kind of alloy, and you have many upsides by doing this. So it's just one tiny example. Everybody use this kind of pens that you use and throw it away, and then you have iridium and osmium on the top of it, on the point of it. And once I was in a lecture, and the guy who was presented, it was one of the major manufacturers of this kind of pens in Brazil. It's called BIC. It's actually a French company, BIC. And he was telling, do you know that 99% of the price that you pay for this pen is just the roller ball on the point of it. It's just the roller ball. Less than 1% is whatever else, plus the logistics to deliver this to you. And we deliver to every single place in Brazil. And here in Brazil, if you go to a cafeteria, you can find these pens. If you go to a supermarket, you can find these pens. It's amazing, the capillarity of the distribution. But they can do all of this with just 1% of the prices of this, and it's almost nothing, like $1 or less than that to buy one of these pens. Okay, and we talk about iridium and osmium. Okay? Do you want anything more technological than this? So let's see beautiful things. Okay, so again, I went online just yesterday and I found this amazing ring. Okay, it's an amazing ring. It's iridium and platinum coated, okay? And of course, there is a diamond over there, but it can be yours with just 117,000 Brazilian reais. So local tax included, of course, if you want. It's willing to sell you this. You can see that all of these expensive things, especially alloys, can be used as jewel. Okay, and someone asked me about jewel. Here you are. You're gonna see jewelry made of all of those. Palladium is the next one. And again, we use to catalytic conversion, but we can also use palladium to different things. I think you all know that we can use some metals in our bodies. They are biocompatible. Just like titanium is biocompatible, we can also use platinum, and platinum can be exchanged by palladium, and you can even mix the two together in one alloy. So yes, you can put palladium inside of people, okay? Mount, cuts everywhere. And you can also make jewel, okay? And this ring, I think it's quite nice, okay? It's a wedding ring, because on the other side, the outer side, you can see one kind of finishing, and inside you can see another one. So you can have a polished finishing, or you can have a different one like this one. And another thing that is interesting, it can absorb hydrogen. And you will say, why? What is the good thing on this? Hydrogen is rocket fuel, okay? So you actually made fuel cells out of hydrogen using palladium. It can absorb 900 times its own volume. So you take a very small box of palladium and it's going to expand, absorbing what? Hydrogen. And it's safely stored inside of palladium. When you use this rocket fuel, palladium starts to shrink back, okay? So it's pretty much a fuel tank that goes out and in, or off and in, as much fuel that you have, okay? And the weight is going to be the same. So you land up in a different land, in a different world, and you just suck it up hydrogen, and your palladium fuel cells just go to expand again 900 times. So it is a very good idea on how to keep hydrogen safely, even for our cars, okay? We can store hydrogen in palladium fuel cells for our cars and drive away just producing water, okay? Clean water for your car. That's quite nice. So taking a look at the twin of palladium, we have platinum. And again, as I mentioned before, you can exchange one for another. And that's why the prices are so interchangeable. When platinum is going up, you shift away from platinum into palladium, and then palladium goes up, and so on and so on. And the applications would be the same. And when you take a look at this, I think it's quite symbolic. Okay, you can have like the male and female couple using different bands or even wedding rings like this. So one used palladium and the other one used platinum. When you take a look, they are similar. Sorry, they are quite similar. But there is actually a lot of history behind, right? So I'm your palladium, you're my platinum, and things like that. I think it's quite nice. If I have money enough one day, I would like very much to give something like this to my wife. She's a chemist. I think she's gonna like it a lot. But nevertheless, we have ruthenium, okay? And now we're talking a little bit more technological approach, okay? We could have this technological approach with the other PGMs, but they are well known. So I try to focus on the not so off-beaten pattern. And the addition of just 0.1%. What is 0.1%? It's something like 1,000 ppm, okay? 1,000 ppm of ruthenium can increase the corrosion resistance of titanium by hundreds of times. I'm a titanium fan, okay? I'm gonna come back to titanium. I literally love titanium. And why I love titanium so much is because of their not only mechanical properties, but also bio properties and corrosion properties. Okay, so titanium for me is like a complete metal. It has everything that I like. But nevertheless, if you put a little bit of ruthenium, you have an even better titanium alloy. So virtually immune to corrosion. So make no mistakes, in the future, your piercings, your implants, they are going to be all doped with ruthenium. okay? And literally, you're going to be able to live your whole life with this implant without having any considerations or regards about corrosion. Okay, really, really nice, right? But we use titanium for other stuff, and I'm going to show you guys why corrosion is so important. For example, to airplanes. And here you have another gel made of ruthenium. So again, if you guys are very, very wealthy, like, I don't know, sheikhs or something coming from Arabia, that's the way to do it, okay? Really nice. Gold, another strategic and also critical material. And then you guys are gonna ask me, why gold? Well, first of all, let's skip jewelry for a while, okay? It's quite important right now for pharmaceutical applications, colloidal suspensions of gold. Okay, these nanoparticles of gold are increasing their application because you can do a lot in order to make our lives better with this kind of components, but you can also use gold in different applications. For example, satellites. Okay, they are critical for satellites and communications. If we want to have this kind of lectures, and I gotta tell you guys, at the beginning, I was really concerned about throw away everything that I knew on how to teach, how to lecture, and then move away to this new age of talking to myself in front of a screen, because that's what I'm doing right now. I can see just one person, and it's Thais, and thank you so much for letting your camera on, okay? I can see her face expressions, and guys, I miss this a lot, because I use this as thermometer, because I look at you, and I can instantly say, okay, they are following me because they are laughing, they are looking at me, the behave, the body language. But now I miss this. Okay? Nobody is interacting with me. So if we want to have the satellites and telecommunications even better, we need gold. Okay, there is no other way to replace it, because for other applications we can replace gold, but not for satellite and communications, at least not so far. Again, aerospace and defense systems, we also use ultra thin layers of gold. Okay, we coated the material with gold because gold can pass on electricity with very, very few heat exchange, and then we have these applications. And least not last, robotics. If you consider that in the future we're going to be hanging around with robots, and I really want to see this future. Okay, I think it's going to be very cool. They're going to be coated in gold also. Okay, that's going to be part of them. So if you want to have a dog and you can afford to have one in your apartment, something like that, maybe you can have a robot dog, and definitely you need gold for that. And if we compile everything together, that would be the jeweller's dream. Okay, we have from platinum, palladium, 8K, 14K, even 18K again, gold, up to the end of sterling silver, okay, would be translated in Portuguese to prata de lei, for those who doesn't know the expression, and rhodium on the top. Again, you can see that everything that is beautiful and shiny can become jewelry. But people have different reaction to these metals, okay? Some people just can't afford to use an earring earring made of any kind of metal, has allergical reactions. So that's why there is some alloys that is better for us as a human being. You don't have this kind of reactions. And that's the titanium case. Titanium is not in this picture, it's going to be the next ones. But rhodium has properties similar. Of course, palladium and platinum. So if you can afford to have an earrings made of something virtually that you're not going to have any interactions, go for palladium and platinum. You would be very, very surprised. But if you don't like the color, you can change and use different colors. As you can see on the left is one kind of finishing, and on the right hand side you have a different finish, a different polish for the same PC. Okay, for the same piece you can have one of the things, and it's quite beautiful. It's bright, and yeah, it's expensive. Okay, so this coming from another website and do the same thing. They just take a look at strategic minerals, and now they bring us the real top three. Okay, according to them, the top three starts with rare earth. Okay, so everybody knows that rare earth are quite important. I'm going to try to tell you why. Okay, so rare earth being the first one, first thing that we want to ask is who is the major producers. So China produced in 2017. It's quite old number, but it's not different than yesterday or last year. 105,000 of metric tons. 105,000. Second place, Australia, 150. Okay, just 20,000. And Russia, the third one, 3,000. So it's amazing, this scale. Okay, Russia only produce 3% of the Chinese production, and Russia is the 30 producer. And one thing that is even amazing is that the fact that China has the biggest reserves of rare earth, and the second place, it's us. We are the second largest reserve of rare earth, light rare earth in the world. Especially one city, one place has the second largest deposit, and it's Catalão, Goiás. Okay, so we literally seated on the second largest deposits of rare earth. And we have other countries producing, as you can see, Australia, Russia, and then United States is going to pop up eventually, and they don't have the reserve that we have. And nowadays, our rare earths go straight to the tailing dams. Okay, we mine it, we process it, and we send it right away to the tailing dams because they are associated with niobium and phosphate, and we don't have technology yet to produce it. Yeah, it's sad. It's a pity, but it is what it is. We can't produce rare earth in Catalão yet. So here you can see some products. Cerium, it's important, but it's not high price as the other one. Bastnasite is not a chemical element, it's actually a mineral. And from this mineral, I forgot my phone on. Let me just silence it for a moment. And here we are. Back in business. So bastnasite can produce the other elements, and you can see neodymium and lanthanum. Okay, and why neodymium and lanthanum are important, I'm going to show you guys in a minute. But here you can see the chemical elements. So lanthanum, yttrium, cerium, neodymium, europium, and samarium, and they are really, really important for technological work. Actually, I have quite of those right here with me in my ears. Okay, so when you talk about magnets, and like this, rare earth magnets, you're talking about neodymium. So what are rare earths? When you talk about this expression, rare earth, what comes in our mind? First, what comes into my mind is mistakes. Why mistakes? Because we're not talking about earth. Okay, so back in the time when people used to believe in alchemy, nowadays I have certainty that alchemy is true. Is just take a look about pyrometallurgy and you're going to see alchemists in real life. But nevertheless, they used to believe that everything in the world was made of 4 basic elements: fire, water, air, and earth. Okay, and they didn't understand that this material was not earth. For them, definitely wasn't fire, wasn't water, wasn't earth, so that's earth. Okay, and they came with this name, earth. And again, back in the time of European researchers dealing with this material, they didn't have a lot of those materials in Europe. So they came with this idea, okay, this is an earth and it is quite rare. It's extremely rare. So let's call this rare earth. Okay, and unfortunately, I don't know why nobody changed the name. And we still refer to those 17 elements as rare earth. Okay, so we keep the tradition. So we're talking about the lanthanum series of elements plus scandium and yttrium on our periodic table. And they have similar properties, true, but not that similar. Okay, so sometimes you need one of those, specifically one of those. Nowadays, I prefer more this periodic table. Okay, as you can see, we have the light rare earth, we have the heavy rare earth, and light and heavy are regarding the atomic number of these materials. Okay, but on the other hand, we have the rare metals. Okay, so when you talk about rare metals, we talk about these orange ones. Take a look and see if you can smell any similarity what I showed you before. Lithium, rubidium, cesium, tantalum, gallium, germanium, indium again, tin, and so on. So why Apple is talking about tin? Because it's a rare metal. So why Apple is showing you in the report and they put over there efficiency, energy efficiency, because it's talking about lithium. Okay, about what the guys are talking about this and that, because the supply is short or because there is a problem of supplying those materials. Now take a look. Can you see iron? Yo, it's white. Can you see phosphorus? White again. Can you see manganese? White again. So when we talk about Brazilian exportations and we're talking about mineral commodities, one thing that's just pop up, it's the low price. So why it's so low price? Because they are important, but they are not critical or strategic. So we have to change this. We have to move into something that is more critical. Because what? The price is going to be high. Definitely. Because people need those materials. Okay? So keep always in mind this chart. This chart is quite important. This periodic table. Okay? So this is something nice for you to print out and put behind you. Say, okay, I'm going to take a look at those guys and I'm going to keep tracking those guys because those guys are the future. And I saw an advertise a few months ago, and it was quite nice. The lady on the advertise, he came and said, what is the technology that serves us today and is going to continue to serve us in the next decade? Okay. I'm not going to say who told us this, but nevertheless, it's quite nice quote. Okay, so for example, this car. Okay, this is a Toyota car, and we all know why Toyota is so important, because they are leader on the car markets. They are top. Okay, they are so important because they use fancy elements like europium, yttrium, cerium, lanthanum, neodymium, praseodymium, dysprosium. See why they are so high tech? Because they are using high tech elements. Okay, so why you're going to buy a Toyota car? Because you buy all of those technological elements with them. Okay, they are embarked, and I would not be surprised if in a few years you arrive in a car dealer and you have like unadvertised what kind of elements you're buying. So like Apple, you're buying now 100% rare earth recycled elements on this brand new car. And say, oh, nice. I like rare earth. Oh, give me those. I'm going to take those with me. Okay. I think that's going to be something that you're going to look forward. Just like, again, headsets. Okay. It doesn't mean a lot to many people, but for other ones, they are willing to pay like $300, $400, or even $600 on a headset. Okay, and why? Because of the quality of the sound. Because they want to play and they want to have a full immersion in that game. Okay, and if you want to have this level of quality for your sound system, you need rare earth. Okay, so I brought you neodymium, and that's all about magnets. It's not only used to produce magnets, keep that in mind, but the magnets application, it is amazing, because we use magnets in many places around us. For example, hard drives. Okay, the old ones, the magnetic drives, and not the optical ones or the electronic ones, but we use them also for wind turbines, and we use them for motors. So I bought a video just for you guys to take a look at how cool those magnets are. So magnets against the Apple, and as you can see, no Apple anymore. Okay, but take a look now in slow motion what happened with the magnets. It's quite amazing, because they collide, and when they do collide, look what happened. They break. It's so heavy, it's strange to consider that this material, this heavy material, is going to just to jump and merge together and even break. It can't afford to collide with each other. Okay, so now against an iPhone, as you can see, I like iPhones, but I don't have one. As you can see over here, You have one iPhone and now you don't. Okay, but the iPhone stands because they made of titanium. Okay, I think this one is nice. It's a very beautiful effect. So as you can see, scientists, they are very, very concerned about their fingers. Okay, don't put your fingers in the middle. I know for sure that you shouldn't do this, because if you do, if you left your finger behind, you're gonna have something like this. Okay, quite beautiful picture, right? Everything just popping up. People, we have those on my lab, and when you use these fingers, we just took them, okay, and we just let them go, okay, in order to put them back on the metallic table, and they just go by itself. You don't need to put it on the table. Okay? You just leave, let it fly. Okay? So against juice, okay, it's cool. It's in the slow motion, right? That's because we have that other camera over there, and in a few seconds, you can see this in slow motion. That's the powerful, I introduce you here, the powerful iron, boron, neodymium magnets. Okay, and we want to produce those in Brazil. Okay, we have some people in the southern part of Brazil working specifically to produce this kind of magnets in Brazil. There are many technologies that we have to develop to produce this. It's not only the thing of, it's repeating. It's not only the thing of go there and perform the pyrometallurgy. You have many steps refining the magnet until you get there. But again, it's quite important for us, okay? Why? Because nowadays we can reduce the consumption, the electricity consumption, if you use a permanent rare earth magnet inside of your motors. So at the past, we have to supply electrical energy to the motor in order to produce the magnetic field, and then you have the motor spinning around. Nowadays, you don't need to put that energy because, yeah, I know it looks like a magic trick, but it's for real. You use permanent magnets. Okay, so you reduce a lot of the energy consumption, and you reduce also the heat generated in the system. Okay, so lanthanum, as you can see in here, sorry, sometimes I mix the Portuguese with the English when I'm getting tired. As you can see over here, we have a lanthanum block, pure lanthanum, and this element is also used in a very nice application, camera lenses. So when you take your iPhone, you don't pay a lot of attention on the lenses of the camera, but they are lanthanum oxide lenses. Okay, so if you want to buy a lens, I strongly recommend you to take a look at the prices. You're gonna pay something like $200 up to $500 one lens. Okay, why? Because the material is expensive. And now take a look at the price of the Hubble Space Telescope lenses, and you're going to be extremely surprised. It's really, really expensive. And it's taking pictures free to all of us, right? Quite nice. So cerium also used in catalytic conversions, but lanthanum and cerium are used together in crude oil refinery. So it's quite strange applications, right? Well, you can imagine that we're going to produce cerium, and we're going to deliver cerium to make what? The same catalyst. So this part of the car, it's being actually robbed in some places in our planet in order to recycle the material inside. So people just go into that junkyards and just stole this part of the car. It pays off because you have copper, you have cerium, you have palladium or platinum, and yeah, a lot of value on these parts of the car. Okay, so nevertheless, here it is. Praseodymium, also important, and used to what? Let's see. Yeah, aircraft engines and turbines. So roughly 80% of all rare earth metals in the world nowadays are going into high temperature superalloys. Okay, so now we're not talking about alloys to use as tools, we're using those as superalloys. This is quite important, people. Just consider something like this. If you have a fail in a structure like this, you're gonna have like 200, 300 people dying instantly. okay? And we don't have time to make maintenance every day in spacecrafts like this. Yeah, it's quite important. So 80% goes to jet, among other applications, aircraft jet engines or jet turbines, okay? And what is the problem with rare earth? Okay, China, especially in the inner Mongolia, they have almost every rare earth in the world, okay? Yeah, that's true. But the problem is, they have a cell phone around here making noise. Okay, someone is going to attend this. The problem is how they are producing this rare earth. Because for a long time, Bayanobu was considered the worst place to be, environmentally speaking, in the galaxy, okay? Because they tend to produce rare earth like this. Okay? Oh, I know we had also our bad history regarding mines, we had slavery, okay? I know all of this, but we can't compare right now bad examples with bad examples. We have to compare bad examples with good examples. Again, I'm gonna come back to CBMM. CBMM is one of the most beautiful companies I have visited in my life. Literally, it's all clean. And they have even a zoo inside of the company. Okay, you can actually see wild animals from the area inside the company. So if you have money like we have dealing with Niobium, you can afford this, okay? Definitely. But rare earth is a good deal. They have money and they have this kind of rare earth production. Okay, so you have to move away from this. This guy, he's literally performing pyrometallurgy of lanthanum, okay? And he's breeding lanthanum smoke. So that's why this was considered one of the most polluted places in the galaxy. So we can't afford to do this anymore. And why Europe is so concerned about rare earth? It's not because it's coming from China. That's not the case. There are a lot of Chinese people living all around Europe. They are very good partners, industrial partners and business partners. But they are concerned with this, the carbon footprint of the rare earth coming from China. And that's why they are eagerly seeking for other suppliers, okay? But green suppliers. Can you imagine, people, the impact of coming to the world and say, okay, we have iPhones here, okay, we're gonna cut the price in half, so everybody want to buy it, but the rare earth coming from China, and the rare earths are produced like this, okay? And this guy over there, he's just 16 years old. And people start to say, oh, okay, I don't want your iPhone. Okay, I'm not going to support this. I don't want a device produced with materials like this and coming from 16 years old people working in this kind of conditions, okay? So you enter and you exit the market instantly. You're not gonna reach $2 trillion market share. Now you understand a little bit why I started with Apple, right? Okay, so everything is connected. So go to aluminum. From the top 3 of this website, the second one would be aluminum. And again, China, the first one, Russia, the second one, 1/10 of Chinese production is a Russian production. And then Canada, Brazil is not even in the picture, but we do produce a lot of aluminum. And aluminum goes straight to where? Another applications are pots, pans, and so on, but we again go to aircraft production. And why? Because it's really highest strength, okay, and very, very light. So when you have this ratio between mechanical properties and weight, aluminum stands out. And normally it pays off, okay? It's the best alloy that we can use. And it's very, very corrosion resistant, okay? It's resistant to corrosion at the same level that you can fly with them in the outside atmosphere. Negative, like -50, and inside you're okay, and you don't have any kind of corrosion between these two temperatures. Okay, so aluminum have a lot of advantages, and that's why many of our plants are made of aluminum. And then we come back to prices. What is the aluminum price? As you can see over here, it's fluctuating, but it's around $2,400 per ton. Okay, per ton. So we're talking a few minutes ago about something who would cost $600,000 per kilo. This costs only $2.4 per kilo. And that's why we have aluminum aircrafts and not rhodium aircrafts or other things like that, because of the price. Okay, of course, we put a lot of things together, but the price definitely has to be considered. Okay, and to end this website top 3, we have titanium. As I mentioned to you, titanium for me, it's very, very impressive metal. We can use it for many applications. One of those, airplanes and airplane turbines too. But I'm very, very eager with this kind of applications. So people who has an illness or a condition and they lost a limb, for example, and has to be replaced. I think it's amazing to give people back what they lost. Okay, and their ability to freely move around is one thing that we have to value. Or lose a hand, lose an arm, titanium can help you with that. Okay, so you can replace part, if not all of your bones with titanium. Okay, we still have some problems to figure it out, but we're in the right path with titanium. And of course, you can do beautiful things with titanium too. For example, this watch, and I'm not sure about you guys, but if I try to use a watch just like this one, and I have a rubber band around my fist, I have some kind of allergic reactions, and sometimes I have the smell come out of that after a few days. So that's why I do prefer to use my watch made of titanium band. Okay, so it's light, it's quite nice because I don't have any problems with allergy or with smell. And when I put it on my fist, I can, of course, feel the difference, the temperature difference. But after like 5 minutes, we are in the same temperature and I can feel it. Okay, so I just forget about it. It's all there, and it's very, very, very tough. Okay, literally, I use a hammer with mine many times and it's still in good condition. So titanium, yes, it's very nice. And when you talk about prices, as you can see, the price is higher than aluminum, but the price is just going down, down, and down. Okay, and now we have titanium almost the same price as aluminum. So I would not be surprised if in the future you get to your window, and when you open your home window, the frame is not going to be made of aluminum anymore, but titanium. Why not? And then you don't need to worry too much about someone force your window in or something like that, because it's going to be virtually impossible. Okay, it's really, really high strength. But another curiosity is what we do today with titanium. And almost 95% of all titanium produced in the world goes to walls. Okay, titanium oxide is used as pink pigment. Okay, so if you want to have a white pink pigment, you just add titanium dioxide. Okay? And it's white like this. Okay, so pretty much all of your walls in your home are doped with titanium. Okay, so you all surrounded by titanium, and not only inside our country, our homes, or our planet, but up there too. Okay, nowadays I'm going to show you on our final lecture how titanium is being held and what we're doing with titanium. And we have now 3D printers for titanium, so you can do additive manufacturing using titanium. And this is a geophysical picture of the moon, our moon. And as you can see over here, we have huge titanium deposits in the moon. Okay, so how we're going to colonize the moon? Titanium. We're going to plot titanium bricks, blocks, and frames, and we're going to construct structures on the moon using moon's titanium, not Earth's titanium. Okay, it's not going to pay it off to transport titanium from Earth to the moon. Okay, we're going to use the titanium over there. And there are many, many films, pictures, stories about space colonization. And one thing that is almost present in all of them, they all share this feature, is we're going to use space research to do space exploration. What I mean by that is, if you want to live in Canada, you're going to have to build your home with Canadian resource. If you move to the Sahara, you're going to have to build your home with Sahara resource. And that's obvious for everyone, right? So you're not going to take lump from the Brazilian forest to the moon in order to have, for example, wooden furniture. You're going to use lunar soil to do everything that you need in the moon, okay? But you're going to come back to moon in the future. Lithium, okay? We have to talk about lithium. And if we don't talk about lithium right now, we're completely out of technology. And there is a lithium rush nowadays. Why? Because of rechargeable lithium-ion polymer batteries, okay? And maybe we're going to see a graphene battery in the future replacing lithium. But again, I think that's probably the gap technology. Okay, the graphene would be the end technology, and the lithium, it's now the current technology. It is going to be the gap technology. So the world's demand on lithium is quite high, and cobalt also is getting higher even because of the lithium. But if you take a look at this small battery, everybody has one 2032 battery. Could be inside of your watch, wristwatch, could be inside of your laptop, in your notebook. But this one, this 2032, it's pretty standard. Everybody can have one for like $3 or $2, okay? But in here you can see that I browse online here in Brazil, one, and it's 35 Brazilian reais, like $7. Why it's so expensive? It's so expensive just because of this word here, rechargeable. Okay, so that's not the regular one that you put in your watch, and when you run out of charge, you just throw it away. This one is rechargeable. Okay, so you put in your watch, and it's quite nice. You move around, and your watch is recharged by itself. Okay, so SWAT and other watch company manufacturers, they are doing this. So just use this, a very small battery. My watch is just like that. Okay, I have a very small battery like this inside of here, but this one is solar. Okay, so I just have to put it on the sun or even on artificial light, and right on the bottle it shows me my battery level. So it has an age for high battery level or a medium battery level or no battery, and it's always high. So I have this watch since 2016, and I never ever run it out of energy. I always high. Okay, yeah, so I cut it a lot my battery costs with this watch, because normally I have to change one battery per year, and I'm now 5 years without changing batteries, so it pays off definitely. Okay, so if you take a look, one battery weighs something around 3 grams, just 3 grams. So how much is the kilogram of these batteries? It's 11,000 Brazilian reais. Okay, so if you consider all of the things that I'm showing you, and I choose to have all of those in kilogram, we're talking about something like $2,000, okay, per kilogram. Remember the aluminum, just $2.4. This one is 2,000. Okay, so yeah, lithium pays off. And cobalt, I mentioned to you, they're also together, cobalt and lithium. So just one quick demonstration about cobalt. And this is quite nice. This is a brand new technology. This journal is from last year, and they are introducing something that can put GM back on tracks. GM did something quite clever. As you know, GM was not very good, economically speaking. Over the last decade, they are closing factories and things like that. Then they have this idea, I'm going to move into Tesla market. I'm going to face Tesla. I'm going to move into e-mobility. And they could develop an Ultium, that's the name of the battery, Ultium lithium-ion battery. And against, according to them, they have, against all the odds, performance way superior than Tesla. Okay, so this could be a game changing for GM for the next couple of years, and they can come back just because of that. So lithium reserves, as you can see, Chile have 7.5 million tons. Okay, after that we have China again, always China, always China. China is a technological blessed country. Argentina, Australia, and Brazil. Okay, so Brazil has 0.048 and is still important to Brazil. So what are my recommendations to Brazil? First of all, start to using boots and go into the camp and research more. We need geologists on the field now, because we do have more potential to increase our reserves, our lithium reserves. Okay, and lithium is not coming out of the picture in the nearest future. So people, in summary, we're going to move now into mineral processing. So we know that they are important, we need them. Mining is nothing that we can just switch off. Okay, I don't want mines anymore. Mines are ugly, they are environmentally wrong. Let's go without them. We can't do this. Okay, we definitely can't do this. So what is the strategy right now? First of all, we have to change how people look at us. Okay, definitely, because nowadays people look down on us. Said, oh, do you remember that accident over there? Yeah, well, we all remember. We lost friends, family, colleagues. Okay, we don't want to be reminded on our mistakes, but we have to remind the world of the need they have of us. Okay, our importance. That should be the strategy. And after that, okay, what are the elements that we need to supply them with? Okay, and then we can sit down and discuss things like this. Okay, you don't like how we're doing this, but we need us. So let's discuss how you would like us to do this. Okay, and let's be friends. Okay, let's do this better. Okay, no mistakes anymore. So pretty much we have to move into this. We have remember the name of our lecture, okay, and our subject, the Brazilian challenge. This is one of the challenges that we're facing right now. Move from the linear model into the circular model. Okay, so circular economy is everything now. At the beginning, we have just take, make, toss. Take, make, toss. I take from the mine. I make products, I use and throw it away, okay? And something magical happening here, people. It's amazing. I'm sitting right here. I take my phone, I order something. I don't know how, but it just appeared in my front door. And then I use it. And when I don't want it anymore, I just throw it in front of my house again, and it disappears. It's amazing. I don't know what happened, but it just leaves my house. Now I have to consider that this item, for this device arrives in my front door, I pay a price. Environmentally speaking, I pay a price. And for it disappears from my front yard, I pay another price. So I have to consider now reuse, refurbish, remanufacture, recycle, and the one that I like most, repair. Okay, repair. And if you take a look at the UK right now, they are putting in motion a change in their law that you cannot just dump a refrigerator or a washing machine. You have to repair it. You have to reuse it. And I think it's quite clever, because the guy was thinking something like this. We're living another slavery, because I'm going to buy a monitor, a new one. And then I'm going to pay 2 years, part of my salary, to pay this monitor. After 2 years, this monitor stops working. Okay, and I throw it away, and I buy a new one, and then I pay again 2 more years my new monitor, and then it breaks again. So I'm a system slave. I never stop paying. I'm never going to be able to come home and say, okay, I don't have to worry anymore about monitor. I have a monitor. Okay, I have to think something like this. I'm using a monitor. Because I'm gonna use and throw again, and use and throw again, and buy another one and use and throw again. So I don't have a monitor. I'm using this monitor. In the future, I'm gonna be using another one. So guys, I want to go back, personally speaking, I want to go back to that moment in time that you used to take a look at a motor or an anvil, and it's written over there, made in the USA. And you could think something like, that still lasts forever. Okay, because if you take a look at tractor parts or something old in your farm that belongs to your grandpa, and you take a look at it's the real pure steel, it's gonna last forever. Okay, and nowadays you buy something brand new, and after 5 years you have nothing. Have nothing anymore. It's just like it was biodegradable, and you don't have anymore. Okay, we have to come back to that time. Okay, we have to have new ideas. We need bright ideas. We need to break the circle, and that's up to you guys. Okay, I strongly think that you guys are going to do this, and you're going to do this in a more environmentally safe way. Okay, because my generation, when we were young, our dream was to have big cars, loud cars, and things like that. Your generation doesn't want to drive anymore. You're more concerned about the carbon footprint than having a car in the garage. And I think you're right. Okay? You guys convinced me that we need to change. Okay? And now I'm completely open to give up on my all cars in order to have, for example, a bus, an electrical bus, that can pick me up here and commute me to work. Okay? And I think that's the way to do it. If I could, I just took my bike and ride to my job without any other consideration. Happily, I would do that. Okay? So yeah, I think we lost something. Do you remember the gap technology? Fossil fuels were a gap technology, and we have to keep that in mind. They're just the gap technology. We have to move away from that. We have bicycles, and we have cars, and now we're gonna come back to bicycles. And I think that's great, okay? And one day I was talking to a guy, and he was looking at me and said, you know something? I'm from a very small town, I'm not educated, but I know something. My grandfather, he used to ride a horse, okay? My dad, he had a bicycle, okay? We didn't have money to afford a car. I have cars, okay? Many, I have cars. I had many cars, I have like 2 or 3 now. But my kid doesn't use car. My kid uses airplane. Quite nice. But you know something? His kid, my grandson, he'll be riding a bike again. Or probably he would be riding a horse. And I said, oh, that's a lie. That's impossible. We're not going to come back on technology like that. And like 20 years after, I'm taking a look at the story again and said, the guy was right. The guy was right. We're going to probably be riding e-bikes again in the future. We're going to have electric bikes around us, and probably it's going to be solar fueled, or you're going to stop somewhere and just plug your bike in and you're good to go in a few hours. And that would be a beautiful, beautiful world. Even better than what we have right now. So people, to summarize and to finalize, and I want to hear a little bit about you, that's the things that we have to consider right now. That's the circle, okay? PV, wind turbines, water quality. Take a look at that one. That one's quite nice. Fossil fuels, okay? We still need fossil fuels for some applications. We have to learn how to do this better, okay? But we're gonna be using this. Phosphates for agriculture, okay? So you can see plants twice because we have the possibility of extract oil from these plants, okay? Recycling. And this recycle symbol should mean more than just recycling. Everything. Recycle, repair, refurbish, and so on. And then again, fossil fuels and the sun. Okay, I think that's very nice to see the sun and to close with the sun. Okay, so this person is holding like a light bulb plant or something like that. And yeah, mine is going into that direction. And I really appreciate if I could be alive in a day that I'm gonna arrive in a mineral processing plant, and the guys are gonna look at me and say, Professor, do you remember that talk that you gave, that speech like 20 years ago, 30 years ago about having a mineral processing plant running on solar energy? I said, yes, we're one like this. We're running 100% solar energy. Now we have something around 70%, but I would like very much to see one running 100% on solar energy, especially the mills. Okay, so guys, thank you so much for today. It was again a pleasure to be here talking to you. And I really wanted to listen a little bit about you and what did you research about strategic minerals. If you couldn't find anything, please just tell us something that you now consider strategic to your country. Please feel free to open your mics, your cameras. It's an open discussion. Go ahead.
Okay, I researched a little bit about zinc. I really think that should be a strategic mineral. Kind of because the possibility of doing things like galvanizing, like these very expensive minerals that you should for us. But here in Brazil, we have ships in the oceans that I don't know, maybe need more of this durability against the corrosion. And also, zinc is used for agriculture, and it's used for. I'm sorry by the noise.
Don't worry.
It's using for healthcare, and we have the next resource here. Isn't a company? It's a Brazilian company. It's I think from Peru. I don't know, but nowadays they have a new project in Aripuanã of extraction of zinc and copper, and I really think our government should consider this element a strategic element, because all the utilities that it have to our development, maybe like agriculture, transport, these high resistant about the corrosion. So is that.
Yeah, I completely agree. Zinc is quite important. And if you take a look, really quickly look at Chile, they were the top copper producer. And they have another element associated with copper, it's molybdenum. And then they start to think, oh, how about produce both? And they become the Molycop project. And then they become the third largest molybdenum producer. And now they are first molybdenum producer in the world. They don't take a look anymore at the copper project without taking a look at molybdenum. So now in Brazil we could do the slightly different, but we could do the same. All copper projects would be like copper zinc projects, and then we could increase our production. Very nice, Thais. Thank you. Who else?
I'm gonna talk as you talking about molybdenum, which is the one that I researched about, and I found out it is a strategic mineral for Brazil. It's an allowing element for stainless steel and other metals. So it's used because it has like a big resistance to corrosion and high temperatures as well, and like in car parts or aircraft parts as well. And it's also used in chemistry industry, I think, for pigments, catalysts. I forgot how it's catalysts, yes. And I found out also that for most uses, molybdenum doesn't have a acceptable substitute, which I found out is very interesting. Also, the biggest producer of molybdenum is China, and they did what you said. They define as a national mineral, so it kind of restrict the exportations of the mineral and also the mining process of it. And also they created like exportation quotas, so they have like 41% of the whole world production of molybdenum, and they control a lot of it and the price of it. And that's it.
Thank you. Very good answer. Very good element. Yeah, molybdenum is quite important. We'll come back to molybdenum in the future. Who else? Come on, guys, at least 2 more people for us to close. Ma, your phone is all again muted.
Yeah. Hi. Yes, as you know, I'm from Suriname. We only the main minerals that are mined here are, of course, petroleum and gold. They have ventured into diamond exploration, but it isn't as large as gold and petroleum mining. So strategically, and I've discussed this with Mr. Finke. He was also a teacher, my teacher at the university. So what we discussed is that petroleum and gold are for Suriname, of course, as of now, economically very strategic, because a few years ago, for example, for petroleum we had a refinery built, so we make our own diesel and oil for driving or for generators, anything in that sense. So oil and diesel is important less, but it's still being imported because our country thrives on imported goods. We don't make a lot of products in our own country. We do have agriculture and we produce our own meat, but for the rest, we import a lot of stuff. So for the strategic minerals, I would say are petroleum and gold. Gold is also very largely mined in Suriname. So beyond that, we don't have enough research. We did discover in the 50s a lot of minerals and other rare elements, but that information has not been stored correctly or updated since 1950 or the 1950s. So it's very hard to say that we have other minerals which could be strategic for Suriname. And in that sense, I would advise, and if I myself could do research to find these minerals and to see what could be the economic value for Suriname. Yeah, so that's it.
Many opportunities, right? You do have many opportunities.
Yes.
We don't have time now, but please remind me next lecture. I'm going to talk a little bit for you about how we should spend money to make more money. Okay, and I think it's something that we in Brazil we should be doing. Okay, we know how to do it, but we don't actually do it. But I think it's the same thing that you should be doing in Suriname. But it's quite nice that you use the word just. You said something like, we just have petroleum, gold, and diamond. I said, wow, just. We do have petroleum, wow, gold, and my God, diamond. Yeah, it should be like this. Wow.
Yes, yeah, we are very proud of it. But if we, I spoke it in a sense of looking at your country, while your country have many more minerals being explored, being discovered, being mined and used. And we do have a lot of minerals because we're in the same basin, Brazil and Suriname and the Guyanas. So there is a large possibility that we do have those minerals, but it's just that we don't have it's not the resources, but the financial push to actually explore those minerals. So yes, we are proud of petroleum and gold and diamond exploration, but yeah,
we're going to come back to this. We're going to come back to this. I think the best thing that you can do right now is alliances. Okay, like academic alliance, bring more professors, more people, for example, from Europe, Brazil, USA. Those guys, they even have the fundings to go to Suriname and perform part of the studies over there. And that's what we did here in the past, and we're still doing this with Germany. We have partners that come and go, and sometimes they stay with us for 6 months. We go there and stay for 1 year, and that's really great because you can strengthen your relationships and your connections with other laboratories, universities. That's the way to do it. I strongly believe that's one good possibility that you should track. Okay, but we'll come back to this. Hamon, you raised your hand? Please feel free.
Okay. In the past, we still have bauxite, aluminium, but in the past, bauxite, aluminium was a strategy. If we think about the Second World War, this end, like 5 years ago, this Alcoa stopped mining, Bilito stopped mining, but there are still bauxite in Suriname. And like what Matumela said, for this today, and what you said, I will push it to try to find a teacher of graduate from Brazil who interested to come to Suriname and to make a training of a joint venture and to grade up the Department of Geoscience. Why I said that? Because in this department, there's more geological in the right of they do more geological study, research, not mining. So I'm a mining engineer, and I really want more mining. But that's I think in the future we will talk more and try to work together with some of the institutes in Brazil to create up and to see. Yeah, that's for now.
Thank you, Ramon. I can't talk about all Brazilian institutes or things like that, but you're most welcome to cooperate with us, okay? Our doors are completely open, and we're always seeking for collaboration, okay, with any one of you. So if you want to have any kind of discussion like that, you have my contact, you have my WhatsApp contact, you have my email. We're open to this, okay? That's what drives us, okay? Have collaboration and have more friends all around the country and, of course, overseas. Why not? Okay, but you'll talk about aluminum, and yes, aluminum is quite important, and I think it's going to be even more important. So, guys, thank you much for your collaboration and for your support. What I'm going to ask you to do as homework is, okay, I'm going to give you 1 week, okay, to search again if you haven't. But if you do, if you already choose your element, write down for me an essay, just 2 pages, top 2 pages, just saying what you just told me, okay? Why this element is important for you or your country and why, okay? And try to focus on what could replace this element, okay? What are your strengths? What are your weaknesses, opportunities, and threats? In other words, try to think in a SWOT matrix, okay? Okay, for example, aluminum. Those are the pro. Okay, you have all these qualities of aluminum. Okay, so this is my strength. Okay, what is my threats? Oh, after World War II, we don't know anything more about the deposit, bauxite deposits of aluminum in my country. I can see that people are stopping using aluminum. Okay, that's my threats. What are opportunities? Oh, as you can see on that graphic, the prices are going up again. So that's really good, okay? So try to write down your essay, like 1 paragraph, focus on one of those topics, okay? And then we'll come with a conclusion. So again, summarizing, a small introduction, okay? Go for SWOT, like SWOT, and then a small conclusion. Okay? And that's going to give us a very good insight how our seminars are going to be. Please, if possible, try to include in your essay concepts about circular economy. For example, aluminum, it's 100% recyclable. It's amazing. Okay, so I can recycle aluminum. Okay, where can I find the Excel file with the names? Oh, I'm gonna send right now. 1 second, I'm gonna post in here in this chat. I'm gonna put also on our WhatsApp group, but you just click on this link that I posted right now, and you're gonna see Excel sheet. Okay, and I can see if you guys are typing in right here. My screen is open right here. But some people already choose some elements, other no. For example, aluminum is completely free, available for you, Ramon, and your group. Okay, so guys, take a look at this. And for example, if you don't like those 12 elements right now, if you want to study another one, not a problem. Just go there, put another line, put the element number that you want to study. For example, Barbara, zinc, and create a new group for zinc. Okay, it's not a problem for me. Okay, we're not limited to these ones. You can propose different elements for, and zinc would be very good idea, okay, to include, because we're gonna study mineral processing of those elements. Okay, and we do have zinc in Brazil, and we do have mineral process of zinc in Brazil. So if you include zinc on this spreadsheet, we're gonna have a seminar about zinc production and mineral processing in Brazil. And that's the idea of this spreadsheet. Okay, guys, we're gonna discuss mineral processing of those elements. So yeah, the zinc would be very nice. And we come back next Tuesday, 7 p.m. Brazilian time.